Vedantu NEET English. I'm Diksha Kaushal, your chemistry master teacher. And bacha, today we are going to start class 12 physical chemistry. And you know what? These are the most scoring and most easy chapters, if you say. Right? I don't know, solution. I feel like this is the most scoring chapter. Why? Because direct questions are asked, okay, predictive questions are asked from you. The questions are not twisted here, okay. Very simple formula based questions are asked, and also the concepts are very simple. So it's a very lightweight chapter for you. So I really advise all of you to practice the questions, because 2 to 3 questions will be asked from solution chapter. So everyone, do join in the class so that we can start this session with full energy. Because exam is come just near to you, right? Exam is like just 2 months away. I would say less than 2 months away. Just 45 days are left for the exam, right? So everyone, with full energy, do join in the session and write it in the chat box. Yes, I want green hearts in the chat box. Everyone in the chat box, green hearts in the chat box. Yes. Okay, so are you excited for this cute chapter? Because this is a very simple chapter, right? Okay, the concepts are going to be full clear after this session. That's my promise to you. If you have any doubt in between the session, I'll ask you if there is any doubt or not. Just answer this, okay? You will feel like this is an offline only, okay? This is what students usually tell me, that ma'am, in your online class also, we feel like we are in an offline class. See, because I like to interact with you, because the reason is that I like to know that are you able to understand what I am trying to say or not. Okay, all the concepts are clear to you or not, because here it's not that I am teaching, it's about what you are learning. So everybody be active in the chat section, and whenever I'm asking you something, do answer that, so that I can also feel that yes, you are getting whatever I am teaching you. Yes, everyone, perfect, perfect, perfect. Ma'am, please do biomolecules. Bacha, I have already done biomolecules. You can see the lecture on biomolecules, okay, in the live sessions. That was actually a 3 to 4 hour class, right, including the PYQs and tricks, everything we have discussed for biomolecules. Okay, yes, Dhi, understood? Okay, so everyone, let's start the session. Okay, so starting the session with the very basic things, okay, with the very basic things to advanced level, everything we are going to cover today, right? Simultaneously I'll ask you PYQs here, so that you can have that thing, okay, whatever ma'am is teaching, that is actually asked in the exam. Latest exam, I'll show you that. Okay? Yes? Okay, perfect. So let us start the session, starting with first is homogeneous and heterogeneous mixture. So you know that 9th class topic which we used to see, that we have true solutions, we have suspensions, we have colloids. Okay, they are the different type of things we have, right? Okay, for that, before starting this, I would like to tell you one thing, that when we talk about solution, whenever we talk about solution, we talk about 2 things. One is solute and the other is solvent. Okay, and the other is solvent. Solute is in less quantity. Okay, solute is always in a less quantity, and solvent is in more quantity, right? This is in more quantity. For example, if you have this water, if you have water in a beaker and you are making lemon juice, okay, you are making lemon juice, right? What you will add? You will add sugar, right? You will add salt, you will add lemon. All these things which are in small quantities, they are called solutes, and that thing which is in large quantity, that means water. Water will be your solvent. And whenever nothing is mentioned in the question, that what is the solvent, we always take water as a universal solvent. Okay, water is taken as a universal solvent. So now let us see one more thing, that how many solute can be there, how many solvent can be there. Always remember, there can only be just one solvent. Okay, solvent cannot be more than one. Like hero cannot be more than one in a movie. Similarly, solvent is just one in a solution. Okay, so let us write here number of solvent particles, not particles, number of solvent, types of solvents. Okay, types of solvents. And here we are talking about solute. Now, bacha, tell me that what do you think? How many solute particles can you have? And along with them, we will name them. Okay, what will be the name of that solution? Okay, so now when I talk about that I have one solvent, solvent will always be one. Okay, solvent is always going to be one here, right? There can be 1, 2, 3 or more than that solutes in it, right? Okay, so let us talk about if we have just one solute, if we have two solute, if we have three solute. Now, if you have just one solute and one solvent, that is known as binary solution. Okay, that is known as binary solution. That is known as binary solution, right? Now, if we have confirmers, ma'am, please. Yes, bacha, that will be done. Don't worry. Okay, after completing physical chemistry, I'll do the confirmers. Okay, don't worry about that. I have that in my mind. Okay, bacha? Yes. Okay, next bacha, we have binary solution. Now, if you have two solute and you have one solvent, in that case, it is called as ternary solution. Okay, that is called as ternary solution. Now, if you have three solute, for example, you are making lemon juice. You have added sugar, you have added salt, you have added lemon. You have three solutes here. One solvent, that is water. In that case, that will be known as quaternary. Okay, that will be known as quaternary solution. Right? So these are the name of solutions. And in this whole chapter, we are going to talk about binary solutions, where we will have one solute and we will have one solvent. And always throughout this chapter, I will denote solute by 2 and I will denote solvent by 1. Right? I will denote solute by 2 and denote solvent by 1. Right? Okay. So now, next categorizing it, we have homogeneous and we have heterogeneous mixtures. Right? Homogeneous mixtures are that which are uniformly distributed, like uniform. Uni means one, right? Where, for example, I have added, this was a beaker, I have added sugar in it. Now, whenever you add sugar in a solution in a water, what you see in that? There is no differentiating factor that this solution is not fully mixed with sugar. In every sip, you will feel equal amount of sweetness, right? Why? Because that sweetness, that sugar is uniformly distributed throughout the solution, right? That is uniformly distributed. Now, if I talk about heterogeneous mixtures, they are not uniformly distributed. For example, this is sugar, and for example, if I add sand in water, what I will observe here, everyone, what you will observe here, you will observe that sand is settled down. Okay, you will add sand and you will mix it for just 1 to 2 seconds or maybe 10 seconds. It will, feel like a uniform solution. But after that 2 to 3 seconds, it will settle down. Once you stop mixing that, it will settle down. That means there is no uniform distribution. That is called heterogeneous mixtures. Right? Okay, these are homogeneous and these are heterogeneous. For example, sand and water, concentrate mixture of nuts, so okay, all these things. Right? All these things are what? Heterogeneous mixture, which are not uniformly distributed. Now let us talk about solution. As I already told you, that solution has two parts, right? One is solute, next is solvent. Solute is in less quantity, solvent is in more quantity. Right? This is the less quantity, this is the more quantity. Here I am writing it. This is the less quantity, and this is having quantity, and this is having more quantity. This is having more quantity. Right? Okay, together they will sum up to make the solution. Right? Okay. Now, this is a chart which is exactly in your NCERT. right? Okay, there are less chances that they will ask you questions from this, right? Very less chances, because this is little, this is not a very, I would say that these questions are also asked in your 9th and 10th classes, right? So I would advise you to go through this once, because it's not a very difficult task, right? Because this is mentioned in your NCERT, and whatever is mentioned in your NCERT, that you must do, right? Okay, now let us see this, let us go through this, what they're trying to say. When you have gaseous solution, now if you call it gaseous solution, the solvent is always going to be gas, right? When I call it liquid solution, the solvent is always going to be the more quantity, okay? The name of the solution is named after the solvent, okay? Or if the solvent is gaseous, that is gaseous solution. If the solvent is liquid, that is liquid solution. If the solvent is solid, that is called as solid solutions. Okay, so now let us look at the examples of it. Okay, now let us one by one look at the examples of it. If they ask you, you have camphor and nitrogen gas. This is solid and this is a nitrogen gas, right? This will be a solid and gaseous solution, right? So let us talk about copper dissolved in gold, right? So now we know gold is solid and copper is also solid. That means solid and solid solution you have. For example, let us talk about, these are very easy, ethanol dissolved in water. This is liquid in liquid, because this is liquid, this is liquid. Yeah, very easy, very simple. Exactly mentioned in your NCERT table, okay? NCERT class, NCERT book. Now, next thing that we have, types of solution on the basis of amount of solute, right? On the basis how much amount of solute that you have added. We have 3 type of solutions. For example, I say, you have this beaker, okay? You have this beaker, okay? We have this beaker. Now, what we are doing? We are adding, what we are adding here? Everyone listen to this, okay? What we are doing? We are adding sugar, right? And we are heating it. And no, currently we are not heating it. We have just added sugar here, okay? We have added sugar here. We are trying to mix it. We are mixing it. It is getting dissolved, okay? It is getting dissolved. But one point will come when the sugar will stop dissolving, right? That is the saturation point. That I don't want to get dissolved more, okay? That is my maximum capacity. I can't get dissolved more into that, okay? It will say no, I can't do this more, right? Now what we will do? We will push it. How we will push it? We will heat it, okay? We are going to heat it. After heating it, we again try to dissolve this, right? That means on increasing the temperature, the solubility is getting increased here, right? So in the same pattern, let us discuss unsaturated, saturated solutions here, okay? So now, talking about the unsaturated solution. What are unsaturated solution? A solution which more amount of solute can be dissolved at a given temperature. Here see always, if we are defining a term that is unsaturated or saturated, the temperature should be constant. There should be no change in temperature. Because if we are increasing the temperature, whenever you increase the temperature, whenever we feel that, okay, this thing is not getting dissolved in the water, what we do? We increase the temperature, we get it dissolved, right? This is what we do in labs, this is what we do in kitchen, right? Okay, same thing, that given temperature, that means temperature should be constant. That is very important here, okay? So temperature should be constant. When the temperature is constant and the solute is getting dissolved in the solvent, we say, okay, this is unsaturated solution, right? Now, when the sugar stop to get dissolved in the solvent, right? That point is called that saturation has occurred here. And that is called saturated solution. Cannot dissolve any further amount of solute at that temperature. We have not increased the temperature, right? Now, what is supersaturated solution? You are like, no, we have to dissolve this sugar. I will dissolve this sugar. You are very stubborn. So what you will do? You will increase the temperature now. When you increase the temperature, when the temperature is increased, the solubility will increase, right? When the temperature will increase, the solubility is going to increase here. So a solution which more amount of solute is more than the dissolved at a particular temperature. Is saying a solution in which amount of solute is more than. That means we have dissolved the more amount, that was its capacity. The capacity was, for example, X amount. We have added here x plus y amount of solute. Now what I'll say, this is super saturated solution. Right? This is super saturated solution. We have already dissolved more the solute that it was capable of. That's how we say this is super saturated solution. Right? Okay? Understood, bacha? Any problem till now? Any problem? Yes, bacha. Ma'am, please tell class duration. Bacha, the class duration, I guess, I'll try to complete the chapter by 8 or 8:30. Right? By 8 or 8:30, I'll try to complete the chapter. Okay? Yes? Yes, everyone? Okay. Now tell me the concentration of solution. Let us talk about the concentration values here that are of use. Okay? We have done the concentration term in some basic concepts of chemistry. From that same concentration terms which are important to you, I am going to discuss here. Okay? Let us talk about few concentration terms. Firstly, bacha, let us talk about two concentration terms that are of use in this chapter. What are these terms, everybody in the comment section? That is molarity, ma'am, and the other part is, ma'am, molality. Okay, molality. Okay, so these are the two important terms, very important concentration terms, very, very important. If you don't know about these terms, you won't be able to get marks in this chapter. That's not possible. Without the understanding of these two terms, getting marks in this chapter is not possible. Right? Okay, that is completely not possible. Right? Okay, so firstly let us talk about molarity. Okay, what is molarity and what is molality? Molarity is number of moles of solute, right? And this is also number of moles of solute. Now everyone in the comment section, what is here? Okay, here we will write number of moles of solute divided by, when we talk about molarity, the thing that you need to remember here is Varun. Okay, what is that? Varun. Okay, Varun means this is R. Okay, this is R, wait, and this is volume. Okay, and this is volume. What do you have to remember here? Varun. Okay, V means volume and R means this molarity. Okay, so here we are going to write Varun, that is volume, and molarity. So here we are going to write volume of solution. Okay, here we are going to write volume of solution, not solvent. Okay, volume of solution, that too in, this will be in liters. Okay, not milliliters, this will be in liters. This is how students usually do the mistakes. Okay, and here bacha, we are going to write mass of solvent. Everybody, what are going to be the units of mass? Okay, in all the concentration terms, we are going to say that weight is always in grams, volume is in milliliters, but here in these two terms, we are going to write volume in liters and mass in kilograms. Okay, in all the other terms, things are weight in grams and volume in milliliters. Okay, so these are the two important formulas. Right? Next thing, bacha, these are the most important formulas. Next thing is how they are going to give you the question in the exam. How they are going to give you the question. The question will not be like, okay, these are the number of moles, this is the volume of solution, this is, no. They will make the things little complicated for you. Right? Not even complicated. Just learn this thing, that will be easy for you. Okay, so now we know one more formula, that is percentage. That is to calculate the percentage. To calculate the percentage, what we do here? See, we have three kind of percentage. Always remember, to calculate the percentage, bacha, we have solute divided by solution. Okay, solute divided by solution into 100, because we are calculating percentage. Percent. Per means 1 and cent means 100. Okay, percent. So 100 will be multiplied by this, right? And now we have these three things here, that we have three kind of things, that is weight by weight percentage, weight by volume percentage, volume by volume percentage. So we have these three things here. See this, bacha, see this. When we talk about weight by weight, when we talk about volume by volume, when we talk about this, okay, things are very simple here. When we talk about weight by weight, this is going to be weight of solute by weight of solution divided into 100. Weight by volume means weight of solute by volume of solution into 100. This is going to be volume of solute divided by volume of solution into 100. Right? So this is easy. Now how they will give you the question, okay? How they are going to give you the question? They will ask you that you have 20% of ethanol solution. You have 20% of ethanol solution. Calculate the molality. Calculate the molality. Now how you will calculate? Okay, they will ask you, this is W by W. W by W percentage of ethanol solution is given to you. Calculate the molality, right? Nothing else is given to you, right? You just have this thing. Now this much ethanol solution. Ethanol solution means you must have solute must be ethanol, solute must be ethanol, and solvent is, that is a universal solvent, that is water, right? That is water. So now ethanol is nothing but this is C2H5OH. Everybody, what is the molecular mass of ethanol? Everybody, what is the molecular mass of ethanol? Everybody in the comment section. That is going to be 12 into 2 plus 5 plus 16 plus 1. Everybody calculate this. What is going to be the molecular mass? Calculate this, everyone. Now, let us see this. Let us see this. What does this defines? This defines that you have weight of solute. If you take the weight of solution, right, this is actually weight, W by W percentage. That means weight of solute by weight of solution. Percentage is given to you. If we take weight of solution to be, if we take weight of solution equals to 100, right? This is 100 grams. Also one thing here, all these terms are mentioned in all these terms we have weight in kilograms and we have volume in milliliters. Okay, in these questions you have weight in grams and volume in milliliters. Okay, yes. Now let us see this. You have weight of solution. You have weight of solution 100 grams. Now weight of solute is going to be in, everyone, weight of solute is going to be 20% of this. That means this is going to be 20 gram, right? You know number of moles. What are the number of moles? Let us say now what is the weight of solvent? Now everyone, what is the weight of solvent? Weight of solvent is going to be, that is 80 grams. Okay, now you know, I always tell you one thing, that whenever I write in place of solute, I will write 2 here. Okay, so this is W2, right, and this is W1, right? This is W1. And everyone, what is the formula for molality? What is the formula for molality, guys? What is the formula for molality, everyone here? What is the formula for molality? Molality is number of moles of solute. Okay, molality represented by small m, right? What is the formula? Yes, everyone, what is the formula? No, ethanol is how you said that 36. Okay, 12 to the 24 plus 5 plus 16 plus 1, that is going to be 5, 10, 12. 12 plus 4, that is 16. 2, 3, 4, 46. Okay, this is going to be 46, bacha. This is going to be 46. Okay, number of moles of solute. That means W1, number of moles is weight divided by, everyone, weight divided by molar mass. Okay, so this is capital M1 into W2, right? And this is in kilograms. This is always in kilograms. If I talk that this W2, wait, this should be W2, this should be M2, and this should be W1, right? And M2 is 46 gram per mole, right? Okay. So now if this is in grams, I will multiply this by 1000, right? This is how you will get your answer. This is how you are going to get your answer here, right? Okay, Vicha, this is how you are going to get your answer. W2, this is W2, this is W1, this is M2. Put the values here, you will get the value of molality here. Okay, you will get the value of molality here. Is this clear to everyone here? Is this clear? Everyone in the chat box, is this clear to all of you? So now, similarly, if they give you something like this, if they give you something like this, that this is weight by volume, that this is weight by volume, right? This is weight by volume. Now you have to identify everything. This will be the volume of solution, okay? This is going to be the volume of solution, right? This is going to be the volume of solution, okay? So what I am going to write here, everything will be same, and they will ask you to calculate the molality, okay? Molality represented by capital M, right? Okay? And the answer will be W2 by M2. This is volume. This is volume. Right? This is volume. Okay? If I say in milliliters, this is volume. So I'll write it here. The volume of solution, everyone. The volume of solution is 100 milliliters. Okay? Is 100 milliliters. Put the values here. This is your V. Okay? This is your volume. This is your W2, this is your M2, put the values here, you will get the value of molarity, right? Okay, so you just need to decode what is given to you, right? Okay, so they will not ask you the percentage. This is how the percentage formula is used this way, right? You know, in colligative property, we use the values like this, okay? Now, these were the two things. Now, let us jump to the third thing that we have is mole fraction. Okay, next we have is mole fraction. So now, bacha, what is mole fraction? Everyone, what is mole fraction? For example, you have n number of components. In that case, what we are going to say, you have n number of components. This is number of moles of first, number of moles of second, plus number of moles of third. Okay, these are the total. For example, I am calculating the mole fraction of fourth component. I'll write number of moles of fourth component divided by total number of moles of all the components. Okay, that is N1 plus N2 plus so on Nn. If I have n number of components here. If I say I have just two components, and also one more thing, write it here. That you have, if I say this is represented by psi, okay, this is represented by psi 4. So I'll say that psi 1 plus psi 2 plus psi 3 and plus so on, okay, plus so on up to n, mole fraction up to n equals to unity, right? The mole fraction of all the components in that mixture is going to be unity here, right? Now, if I talk about two components here, I'm talking about two components. I'll say mole fraction of 1 is going to be N1 divided by N1 plus N2, right? Mole fraction of 2 is going to be N2 divided by N1 plus N2. And I'll say that mole fraction of 1 plus mole fraction of 2 is going to be unity here. So these are the three standard formulas that we are going to use in this chapter, right? Okay, everyone, till now any doubt, and also one more thing. If we talk about ppm, that will be just in case of ppm, you will multiply this by 10 raised to power 6. That's it. That's the only difference here. Okay, that's the only difference here. Yes, bacha. So these are the formulas that are written here. So we have done all the formulas. Now, one more thing is written here, that molarity is temperature dependent. Why molarity is temperature dependent? Everyone, why molarity is temperature dependent? And what about the other concentration terms? Are they temperature dependent? What about molarity? What about mole fraction? All the other terms, are they? Ma'am, will you molarity question? Yes, bacha, I'll complete everything. Don't worry. Okay? Okay. Yes, bacha. Okay. Yes, bacha, that is enough. Don't worry, that is enough. Okay. Yes. Now, let us talk about this. Let us talk about this. Now, bacha, you have this one. Wait. You have this thing that is. Wait. Okay, we were talking about temperature dependence. Okay, always remember one thing, that temperature is directly proportional to, temperature is dependent on the volume, right? If the volume is dependent on the temperature, if we increase the temperature, volume will increase, right? So similarly they are saying all the quantities, right here one thing, all the terms that are dependent on, that depend on temperature, that depend on volume, will depend on temperature, right? Okay, so now tell me one thing, if I say why molality is independent, because molality is equals to weight of solute, number of moles of solute, weight of solvent into 1000. This is molality. There is no volume function here. But when we talk about molarity, here we have volume. It is dependent on the volume. That means it will be dependent on the temperature also. Now, if we talk about mole fraction, everyone, tell me, is mole fraction dependent or independent? Is mole fraction dependent or it is independent? Everyone here? Yes, due to volume. Is mole fraction dependent or independent? If we talk about some other term, let us talk about W by W percentage. Okay, W by W percentage. Let us talk about W by V percentage. Right now, tell me, out of these, which are dependent on temperature, which are not dependent on temperature? Yes? Okay? Yes, very good. This is independent because there is no volume in this. There is no volume involved in this. This is no volume is involved in this. This is also independent. Here volume is involved in this. That is why it will be temperature dependent. Right? This is going to be temperature dependent. Right, everyone? You just need to remember this one thing and all the questions regarding this will be sorted because no cramming will be here. Right? Okay? Yes, bacha? Okay. Now let us talk about this one formula. You just need to know this one formula, right? No need of derivation of this formula, right? This is the formula which relates molarity to molality. Okay, when they have given you molarity and they ask you what is the molarity, right? This is the formula that relates molarity and molality directly. Okay, so here you have M. That is molarity. Molarity equals to molarity divided into 1000 divided by 1000 to density minus molar mass into molar mass of solute. Okay, understood this? This is a very simple formula directly that is asked. Okay, very simple formula. Question in your NCERT is also given regarding this formula. Right? Okay. Now let us talk about the mole fraction. We have done that. Okay, have we done the mole fraction? Yes, ma'am, we have done the mole fraction, right? Okay, now let us directly jump to the questions here. Which of the following is independent? Which of the following is dependent on temperature? Tell me, bacha, which of the following? Good evening, bacha. Very good evening, beta. Very good evening. So, which of the following is dependent on temperature? Now, everyone, molarity, mole fraction, weight percentage, molality, which is dependent on temperature, where you will see there is volume involved. So in which of the following volume is involved? Volume is involved only in this formula. Okay, so this is NEET 2017 for 2017 question. Okay, answer is going to be A. Okay, A is going to be the correct answer here. Now next bacha, next we have what is the mole fraction? This is in 2011 and 2015. 2011 and 2015. What is the mole fraction of solute in 1 molar? This is molarity is given to you, aqueous solution. They are asking you the mole fraction here, everyone. They are asking you the mole fraction. and you are given with the molality here. You are provided with the molality here. Molality is given to you, right? Molality is given to you. So how do you calculate the mole fraction? Everyone here, molarity is given to you. That is 1 molar. Okay, 1 molar. 1 molar is given to you. Right? Okay. So what is the definition of molarity? Molarity is number of moles. Everyone, this is number of moles. This is number of moles of solute. Number of moles of solute in 1 kilogram, or you can say 1000 gram of solvent, right? Okay, here they are saying aqueous solution. That means see students, aqueous solution means the solvent is going to be water, right? This is going to be water. That means 18 is going to be the molar mass, right? Okay, so write it here, that is M1 is going to be 18. Okay, what about number of moles of solute? Number of moles of solute in 1000 gram of solvent. If weight of solvent is taken to be 1000 grams here. If we take the weight of solvent to be 1000 grams, in that case we can say the value of N2, that is number of moles of solute. Okay, number of moles of solute, that is N2, is going to be, everyone, what is going to be the value? The value that is given to you in terms of molality. That is 1. Okay, that is 1. Write it here, 1. Okay, that is 1. This is N2 value, right? So calculate N1 here, N1 is equals to, this is weight of solvent, that is W1, right? Okay, so this will be W1 by M1, that is going to be 1000 divided by 18. This is going to be your N1 here. Just put the values here, put the values of mole fraction of, they ask you the mole fraction of solute, that is mole fraction of 2. Okay, that is going to be N2 divided by N1 plus N2. Okay, just put the values here. N2 is 1. This is also 1, right? 1. This is 1000 divided by 18. And just put the values here. You will get the answer. Okay? Yes? Okay, bacha? Yes? Perfect, perfect. Okay? Yes. Okay? So now let us see, after calculating the answer comes out to be this much. Okay? After doing the calculation, the answer is going to be 0.0177. Calculation is your task. Okay? Calculation is your task. The calculation, the answer is going to be 0.0177. Okay? 0177. The answer is going to be, C is going to be the correct answer here. Okay? Yes. Now, next question here is, how many grams of concentrated nitric acid solution should be used to prepare? Now, what they are asking you, NEET 2013 question. 2013 question, everybody. What they are asking you, how many grams of concentrated nitric acid? They are asking you the grams of this. That means weight of this should be used to prepare this much of this molar. This is molarity is given to you. Okay, the concentrated acid is 70% HNO3. This is a good question. Everybody, this is a good question. I'm feeling very dehydrated right now. I don't know why. Maybe because in north now, in north side, the weather is changing actually. So when the weather is changing, there is summers, there is winter, mixture of summers and winters. So sometimes you feel really warm. That's why I feel really dehydrated. But sometimes in the change of season, usually people fall sick. So that's why I'm wearing all these full sleeves and all that. I'm feeling very dehydrated right now. So how many grams of concentrated nitric acid? That means this is the solute. Okay, this is the solute, bacha. This is the solute. How many grams? That is W2 they are asking you. W2 they are asking you. Should be used to prepare. Should be used to prepare 250 milliliter of 2 molar HNO3. Okay, you have to, this should be the molarity. This should be the molarity. Okay, this is the molarity that is given to you, right? Okay, the concentrated acid is 70% HNO3. Okay, this is going to be 70% HNO3. So see this, you have this molarity. The molarity of the solution is 2 molar. In that, the solvent, the volume of solvent is given to be this much. Okay, and the concentrated acid that is used as having 70% HNO3. So firstly, okay, from this calculate the weight. That won't be the actual weight. Okay, so applying this formula, that is molarity is equals to weight of solute, right? Number of moles of solute, volume of solution into 1000, right? So here what you will have, what are all the things that you have? You have the value of molarity, that is 2 is given to you. You have the, this is what you have to calculate here. Okay, W2 is what you have to calculate here. Concentrated HNO3, this is M2, you know what is the value of M2, right? Just apply HNO3. Okay, HNO3, what is the going to be the answer? 1 plus 14 plus 3 into 16. This is going to be the value of M2 here. This is going to be the value of M2 here. Right? Volume is given to you. Yes, volume is also given to you. Volume is also given to you. Everything is given to you. Just calculate the value of W2 here. Right? But this will not be the correct answer here. Because this is for 100% HNO3. You have 70% HNO3. Right? So you will calculate the 70% of this thing that is given to you. Right, you will calculate the 70% of this thing, the weight that is given, that you have calculated. For example, let us see, wait. See, you have applied this formula, right? After that, you know the value of weight here. See, you know the value of weight here. You have calculated the weight here, right? Molarity, you have written the molarity, 1000. This is 250 milliliter that is given to you. This molar mass of HNO3 comes out to be 63. You have put all the values into this. You will get the value of weight of HNO3 as this. Now this weight that we have calculated is for 100% concentrated acid, right? This is for 100% concentrated acid. This is for 100% concentrated HNO3. But in the question they are asking you about 70% HNO3. For 70% HNO3, what you will do, you will just multiply this with 70%. What is the 70% of this mass? Okay, what is the 70 mass of acid into 70 divided by this? That means 70% of this. Okay, that means 70% of this. So the answer is going to be mass of acid. Okay, that you have. Okay, so mass of acid into this comes out to be 63/2 and the mass of acid comes out to be 45 grams. Okay, students? Yes. This is your mass of 100% HNO3, right? You have to calculate the concentrated acid is this much. They have asked you. Okay. So now to calculate the mass of acid, that is 70%. What you will say, we know the formula that 70% of this will be equals to, for example, I am saying mass of 100%, mass of 100% equals to, no, not like this. I'll just write it here. Mass of 70%, right, into, this is the 70% of that. Okay, this is the 70% of that. 70% is what means we have 70 divided by 100, right? For example, you have this beaker. Let me show it diagrammatically. For example, you have this one beaker. Okay, here you have till this time you have 100% of it. Okay, the 70% of it they are asking you, that you have 70% of it. Now you have calculated the 100%. Out of that, what you will calculate the 70% of that. Okay, out of that you will calculate the 70% of that. And how you are going to calculate it? Very simple. That is mass of that acid into 70% of that acid is equals to this, right? Okay, so wait. I have told you the opposite. Wait. That's why there was this confusion. Wait. Just wait. Okay, so This was actually the 70%. This is the 70% of acid. This is the 70% of acid. Yes. So here you have, wait. So here you have 100% of acid, right? Okay. So, and this is the 70%. Okay. 70% of that. 70% of acid is going to be 70% of that acid is going to be this much. Okay, so let us directly write it as 70% of that acid is how much. Okay, so here what they have given you, that you have a beaker. Okay, what they have given you, that you have a beaker. Okay, this is the beaker. Okay, in this beaker you have 70% HNO3, right? Now they are asking, they have given you the volume, they have given you the volume also, they have given you the molarity also, right? And after that you will calculate the W here, that is you have calculated the weight of this 70% HNO3. Now they are asking you the weight of, how many grams of this is a solution this should be used. Okay, how many grams should be used. Okay, they are asking the concentrated, proper concentrated, not 70%, they are asking you the 100% concentrated here, right? So in that case what you are going to say, that from this we will calculate the 70% acid. We will calculate the 70% acid, that is going to be 70 by 100 into mass of acid, into mass of acid, right? And this is going to be 70% of that is 63 by 2, right? This is 63 by 2 that you have calculated from this one. Okay, from here what you have calculated, that weight comes out to be 63 by 2, right? This was the weight here. Just put the weight here, what you will get, the mass of total concentrated acid, the mass of, I would say, mass of 100% concentrated acid, okay? So this 70% weight is equals to 70% of mass of 100% concentrated acid, and from here you will get the mass of 100% concentrated acid. This is what they are asking you. Okay, this is what they are asking you. Yes, bacha. Okay. Should I explain this again? Okay. See, you have this beaker. Okay. In a beaker, I will explain it again. Don't worry. Okay. Should I explain again? Yes. So they have given you a beaker. Okay. They are saying that you are adding. Okay. You have this. For example, they are saying you have this concentrated. You have 70% HNO3. They are saying you have 70% HNO3. You are given with the molarity here, that is 2 molar. That is 2 molar. You are given with the volume here, that is 250 milliliter. Right? Okay. So after this, you find out the weight of acid here. That comes out to be 63 by 2. So now this weight is the weight of 70% HNO3. But they are asking you how much weight of concentrated HNO3 you should add here. How much weight of concentrated 100% HNO3 you should add here. Right? Here you will calculate the weight of, that we will say the weight in the beaker. Concentrated means what? What is 70% concentrated? That means 30% is diluted here. Right? So here we have calculated the weight of 70%, not 100%. But in the lab, we will add the concentrated acid, 100% concentrated acid. Right? From here, we will add the 100% concentrated acid. 100%. So, how to calculate the weight of 100%? That will be equals to, that is going to be equals to 70% of weight of 100% concentrated acid. Right? Is going to be the answer here, that is 63 by 2. Okay, this is what you have calculated from this part, that this much is needed. Okay, this much is, either you can write it this way, but this is not the mass of, this is the weight of, 70% concentrated acid. Okay, And here you need to calculate the weight of 100%. For that, just calculate this. The weight of 100% concentrated acid, this comes out to be 70 by 100. This is mass of acid that is fully concentrated into 63 by 2. Then you calculate the mass of acid here. Okay? Any problem? Yes. Okay, perfect. So now, next let us start from solubility. Okay? What happened to me? I think so much dehydration. Oh God. These summers are going to kill me now. Okay, so now we have solubility. What is solubility? Is the dissolution of solute in the solvent. Right? When we dissolve the solute in the solvent, that is called the solubility. Now we are going to see the solubility for different things. Okay, firstly we will see the solubility for solid in liquids and for gases and liquids. And here we will see the Henry's law also. Right? So let us see the solubility. Solubility, like it depends on different factors. Okay, solubility of substance is a maximum amount of solute that can be dissolved in the specified amount of solvent at a specified temperature. Why they have written specified? Because it changes with temperature, it changes with the nature of solute, it changes with the amount of solvent that you add, right? So it depends on the nature of solvent, nature of solute. Some solutes are very soluble, like sugar is very soluble. But if we say anything like paper or anything is not very much soluble, right? It's not soluble. If we say we have big beads, okay, big balls, okay. So in that case, when you have these big sweet balls, no. So in that case, they are not very soluble. If we say crystalline sugar is like less soluble as compared to the powdered form of sugar, okay. So in that case, what we say, surface area dependence. Right? Okay. So it is dependent on the nature of solvent as well. What kind of solvent is there? Is it even, what are the interactions between these solute and solvent? If this is polar, they will get easily dissolved. This is non-polar, they will get easily dissolved. Because we know like dissolves like. Polar dissolves polar. Right? So it depends on the nature of solute, nature of the solvent. Right? Next we have temperature. As we increase or decrease the temperature, this will depend accordingly. See, why accordingly, ma'am? What is the reason behind that? Because when I talk about temperature dependent, but when I talk about, and I have added solid in liquid, the temperature dependence with temperature is going to be different. In case of gases, this is going to be totally different. So, okay, so we will see how it again depends according to the temperature and according to the pressure given in the given conditions that we have. Okay, so firstly let us talk about the solids in liquid solutions. So always remember whatever I am saying, that is, you have this glass of water. You have this water, you are adding sugar crystals to it. You are adding sugar, you are adding salt to it. Just imagine that, okay? Just imagine that, okay? Whenever you are doing this. Okay, very good. Yeah. So solubility of solids in this is this. Greatly with the nature of solid and liquid, temperature, too much lesser extent of pressure. Now see this. Okay, when we talk about, see, firstly let us talk about dissolution and crystallization. Let us talk about what is dissolution and what is crystallization. These are exactly your NCERT lines. Yeah, these are the paragraphs from your NCERT. You can check that. Okay, these are exactly from your NCERT. Right? You have this thing. Okay, you have this thing. So now let us see this. You have this beaker. What I am adding here? I am saying that I have water here. Okay, I have water here. Okay, ma'am, perfect. We have water here. Now I am saying that I am adding sugar here. I am adding sugar to the water. Okay, while adding sugar, the sugar molecules will be added here, right? The sugar molecules are added to this, uniformly distributed here. Right? A point will come here. Similarly, in case of equilibrium, we have just done equilibrium one day before. Okay, like we know, the reactants were getting converted into products and products back into reactants. Similarly, one thing is going to happen here. What is that, ma'am? What is that? See this. Now, this is a very interesting thing to know, that We say saturation point has achieved. We say no more sugar can be dissolved into this solution. But what if I say the sugar is continuously getting dissolved? The sugar is continuously getting dissolved. What is happening here? For example, if I say this is one particle of sugar, okay, this is one particle of sugar that was getting dissolved here, that got dissolved here, it got converted into blue dot. Okay, it got converted into blue dot, it got dissolved here, right? If I say I am adding, this has reached its saturation point. Now no more solute can be added, but I am still adding sugar here. I have still added sugar, okay? With pink sugar, pink dots are for the undissolved sugar, okay? Pink dots are for undissolved sugar, okay? And the blue dots are for dissolved sugar, okay? These are for dissolved, these are for dissolved sugar, these are for dissolved sugar, and these are for undissolved sugar. These are undissolved sugar. These are undissolved sugar. Now what if I say that actually if I add more amount of this undissolved sugar, right? We say, ma'am, this has reached its saturation point. This will not get dissolved. But what if I say this will get dissolved? This pink dot is going to get converted into blue dot, okay? This is going to get converted into blue dot. But simultaneously, this one blue dot, that means this dissolved sugar is going to get converted into this pink dot. That means simultaneously after saturation, when no more sugar is dissolved here, it's not that sugar has stopped dissolving. It's just that simultaneously there is dynamic equilibrium between what? Between rate of, what is this called? What is this? The conversion of undissolved to dissolved. This is dissolution. This is dissolution, right? And what about this? When we say the undissolved sugar, the dissolved sugar is getting converted into undissolved. There is crystallization. There is crystallization. Okay. So this is what we say that at saturation point. This is what we say, bacha, that at saturation point, or we can say saturated solution, the rate of dissolution equals to rate of crystallization, okay? This is what happens at that point where saturation point is observed, okay? Yes, bacha, everyone, any problem here? Any problem here? So these are small things that we ignore while studying, right? These are not very difficult things. These are very easy things. We ignore these things. That's why we just, the basis, the foundation is not strong. That is how you find it difficult to solve the questions, okay? Yes, is this 100% dissolved or crystallization? Ma'am, at saturation point, is it 100% dissolved or crystallized? At saturation point, for example, I have said that 100 gram of sugar I was dissolving. After 100 gram, no more sugar is getting dissolved in this. Then I will say if I add 101 gram, this will not get dissolved. This 1 gram is going to get undissolved here. But I won't say that this one particular molecule is not getting dissolved. I will say simultaneously, like we used to say, the reactants are getting back into products and products back into reactants. That means there was dynamic equilibrium. That is how here we have equilibrium with dissolution and crystallization. There is dissolution going, there is crystallization going, but the concentration of sugar that is dissolved is constant here. That is not changing. There is simultaneously change in the dissolution and in the crystallization. That means the rate of dissolution is equal to the amount of molecules that are getting converted. Firstly, there was just dissolution, okay? Before, there was no crystallization when the solution was unsaturated. After reaching the saturation point, when there is just saturated solution, no more solute is added here. No more solute cannot be dissolved here. So this doesn't mean that the added solute is not getting back to is not getting dissolved. I am saying this is also getting dissolved here, okay? This pink dot that I have mentioned here, Oh my god. Okay, this pink dot is also getting dissolved here. But simultaneously, some other molecule is getting crystallized here. Okay, some other molecule is getting crystallized here. On adding the sugar here, this is getting dissolved and some other molecule is getting crystallized. Yes? Okay? Any problem? Yes, okay, bacha. Now, let us see this. Okay, this is what they are saying. This is dissolution, this is crystallization. That at the stage when two processes becomes equal at same rate, the stage of concentrator of this solution will remain constant under the given conditions, temperature and pressure. If temperature and pressure are same for a given solute and solvent, they will be at equilibrium. The rate of dissolution will be equals to rate of crystallization. Yes, everyone? Understood? Any problem? Okay, perfect. Nature of solute and solvent. Now, how they are dependent on nature of solute, that I have already told you. Like dissolve like, that means polar dissolves polar. Polar dissolves polar and non-polar dissolves non-polar. Okay, any example of that? Any example of that, bacha? For example, I am saying that any polar molecule like ethanol, they will get dissolved in the water. Water is a polar molecule. Now benzene is a non-polar molecule. Okay, so the non-polar molecules are going to get dissolved in benzene. Okay, for example, the polar molecules will get dissolved in water and the non-polar molecules will get dissolved in benzene. Okay, this statement you must have read in so many other chemistry related lessons, right? Okay, so many other chemistry related problems you must have seen this. Now let us see about the temperature and about the pressure. Firstly, let us talk about the pressure. With pressure, they are totally independent of the pressure. There is no effect. Okay, there is no effect of pressure. Now ma'am, why there is no effect of pressure? Because solids and liquids both are incompressible. They are not compressed. Can you compress this solid? Can I compress my phone here? Can I, if I feel like I want to compress my mobile, can I compress it? Can I compress it? No, I cannot compress it. Right? So what I will say here, that there is no effect of pressure. There is no effect of pressure on this. Okay? If we increase or decrease the pressure, the solubility has no effect on this. Right? Now let us talk about the temperature. What we have read in solubility, what we have read in equilibrium. We have read it yesterday only. Yesterday only we read one thing. What was that? What was that? That ma'am, if we have, see everyone, wait, if we have exothermic process, right? If we have exothermic process and if we have endothermic process. For endothermic process, temperature is directly proportional to the equilibrium constant, right? And this is temperature is inversely proportional to the equilibrium constant. Same with the solubility. In place of equilibrium constant, I am using solubility. Now ma'am, why I am using solubility? Why solubility, bacha? Because solubility we know that is dependent on KSP, right? KSP is nothing but it is equilibrium constant. KSP is also kind of equilibrium constant, right? Okay, so here we say if it is directly proportional to equilibrium constant, that will be directly proportional to the solubility, right? Okay, so simple thing that for exothermic reaction, with increasing the temperature, solubility decreasing. With endothermic reaction, with increasing the temperature, solubility increases. Okay, so this is this endothermic. The solubility should increase with increase in temperature. That is directly proportional, right? That is directly proportional that I have written here. And here exothermic, it should decrease. That is inversely proportional. Yes, bacha. Okay, simple thing. For solids, I'll write it here also. I'll write it here also. No, I'll write after this. Okay, I'll write a nutshell after reading about the liquid gases also. After studying the gases also, we will write the full note chart of that. Yes, students. Okay. Okay. Now, led by hydrolysis. Okay, you give me my new phone. I'll do that. Okay. I'll do that. You give me my new phone, right? Okay, and I'll do that. Yes, that's my promise. Now, solubility of gas and liquids. Now, if you say solubility of gas and liquids, now gases are compressible, right? Gases are compressible. So, for temperature temperature and pressure, how they are dependent. See this bacha, let us see for temperature and pressure how they are dependent. For temperature, you say, ma'am, this is also exothermic, endothermic. No, here we will not say anything about exothermic, endothermic, because whenever you have this beaker, okay, when you have this beaker, let us talk about the gases, okay, let us talk about the gases here. When you have gases in this now, because gases are like free molecules. If you increase the temperature, the kinetic energy will increase. If you increase the temperature, the kinetic energy is going to increase. The velocity is going to increase, the kinetic energy is going to increase. That is why solubility is going to decrease here, right? On increasing the temperature, solubility is always going to decrease here. Right, so I'll just write it here that temperature is inversely proportional to the solubility. Temperature is inversely proportional to the solubility. Yes, okay. Yes, bacha. Okay. I don't have iPhone. I have Samsung. I have Samsung ka phone. Right? Very happy with Samsung. Before that, I used to have M1. We are Android fans. So now, bacha, we have pressure. If we talk about pressure here, let us talk about pressure. Okay, pressure is very interesting in this. Okay, now here you have gases. Okay, gases are dependent because gases are compressible. You know, liquefied gases we use, all these gases. Why? Because they are compressible. They can combine in very much small volume and in large volume. That is how there is diffusion, right? Okay, so that means gases are compressible. When you increase the pressure, I am increasing the pressure. The molecules are getting near to each other. When the molecules are getting near to each other, that means the solubility is getting increased here. So that means on increasing the pressure, solubility is getting increased here. Right? This is also Henry's law. This is what Henry's law states that. Okay? This is the definition of Henry's law. We will study that in detail. Yes, bacha. So now should I write it in nutshell what we have studied till now? Everyone here, what we have studied till now? Tell me in the comment section. If I talk about solids, now bacha, this is your turn. This is recap. Okay? Recap. I am writing it here. Recap. Recap. Everyone, firstly there were solids. Firstly there were solids in liquids. Okay? Solids and liquids. Then bacha, what we have? Everyone, then what we have? Okay. Then what we have? We have gases and liquids. Gases and liquids. Okay. So firstly, let us talk about solubility here. Let us talk about temperature. Let us talk about pressure. This is about temperature and this is about pressure. This is about pressure. This is about pressure. Right? So if we talk about pressure here, how it is dependent? Everyone, recap. How it is dependent? Solids and liquids. Solids are incompressible. No effect here. What we will write? No effect. Okay. What we are going to write? No effect. No effect will be present here. Right? Okay. If we talk about gases, we increase the pressure. The gases are going to get closer. And on increasing the pressure, the gases will have more solubility. Right? This was about gases. Right? Let us talk about temperature. Right? If you have exothermic and if you have endothermic. For endothermic, this is for exothermic. For endothermic, this is directly proportional. Right? Temperature is directly proportional to solubility. Right? Or you can say solubility is directly proportional. Right? Here temperature is inversely proportional to solubility. Right? Now here we'll have temperature is always inversely proportional to the solubility. This was your recap, right? Okay? Yes, everyone. Any problem here? Any problem here? Yes, students, any problem? Is this clear to all of you? Is this clear? Any problem here? Everyone. Yes. Okay. Shall I move? Shall we do the next topic? clear? Okay, perfect. Okay. So now let us to the next topic, that is Henry's law. Okay, Henry's law, very interesting law, right? There's also applications that are very interesting. Okay, very interesting applications. So now what Henry's law states that whenever you are applying the pressure, it is increasing the solubility. Right? We know that whenever we apply the pressure, it is increasing the solubility. Right? This is what Henry's law states. Now, according to Dalton, what he said that mole fraction is the factor of solubility. That if you want to express solubility, you can express solubility in terms of mole fraction. Okay, solubility can be expressed in mole fraction, right? So here we will write that we can say, I'll just draw my own, okay, I'll just write it in another page. That is, we say pressure is directly proportional to solubility. But according to Dalton, what he said, solubility, mole fraction is a factor of solubility. You want to measure solubility, measure the mole fraction. That defines the solubility factor. Okay, so here we will write this is a mole fraction. If I am talking about something here on when we raise the proportionality sign here, okay, what we write it here, this is KH. Okay, this is KH into mole fraction. Okay, this is your Henry's law. Now ma'am, how we draw the graph? Okay, this is, I am drawing the graph between, this is partial pressure and this is mole fraction. Okay, y is equals to mx plus c. This is the graph of straight line. Yes, this is the graph of straight line, everyone. So let us draw the graph here. Everyone, let us draw the graph here. Let us draw the graph here, okay? This is your graph, okay? This is your pressure that is on the y-axis. Guys, see, this is your pressure that is on the y-axis, right? And this is your x that is on the x-axis, that is your mole fraction. This is your mole fraction, right? And if we talk about the slope is nothing but this kh, that is Henry's constant. Right? So what about the intercept? The intercept is going to be 0 here. There is no c. There is no intercept here. So you will write this is the straight line that you will get for Henry's law. Right? This is a straight line graph. Right? This is what they are saying here. Now let us see the units and all these things about the Henry's constant. Unit of kh is torr or bar. This is called torr or bar. Different gases have different value of kh. For different gases, we have different values of kh. That is also mentioned in your small table of NCERT. That is mentioned, but nobody is going to ask you that. Okay, you can just you can see what is the decreasing or increasing order of kh values. Okay, go through the decreasing or increasing value of kh values. Order of kh values. Order of kh values. Okay. From your NCERT table, go through the order of kh values. You don't need to remember that. Okay, you don't need to remember each and every value. Just go through the order which has least kh value, which has maximum kh value, and that too just that are mentioned in your NCERT. Okay. Next is kh values of gases increase with increase in temperature. Why kh value increases? With increasing when temperature is increasing, solubility is increases. That is how kh value is increasing. Right? Higher the value of kh of gas, lower will be the solubility. Right? The more is the value of kh for a constant pressure. We say pressure is constant. Right? We say this is constant. We say this is constant. If pressure is constant, in that case, we will say mole fraction is inversely proportional to kh. If we say pressure is constant, partial pressure of that gas is constant, right? And in that case, mole fraction is inversely proportional to the value of kh here, right? Okay. Now, let us write some values of kh. How kh is dependent. What are the characteristics of kh? Different gases have different kh values at same temperature. Right? You have different gases have different kh value when we talk about same temperature. Right? This suggests that kh is a function of nature of gas. This is dependent on the nature of gas. Then higher the value of kh, lower is the solubility in the liquid. That is, they are inversely proportional. That is, when you have partial pressure constant, it is due to the reason that aquatic species are more comfortable in this. Now let us talk about this very important point that can be asked in your assertion reasoning questions. Okay, this is how assertion reasoning questions are formed exactly from your NCERT lines. Okay, this is how they will be formed. Now let us see the application. So in that I will teach you that. Okay, so firstly the application, the very first application, everyone, is cold drinks. Okay, very first application is cold drinks. So everyone in the comment section, how in cold drinks, you know that if I say that this is a bottle of a cold drink, okay, this is a bottle of a cold drink, a Coke, right? What I'll say here, carbon dioxide gas is dissolved under high pressure, right? Higher is the pressure, we know that. Higher is the pressure, high will be the solubility of gas, more will be the solubility of gas. So to dissolve carbon dioxide gas, the carbon dioxide is dissolved under a very high pressure. That is why whenever you drink it, the pressure is still there. You will feel it in your burps or in your, nose also you feel those burps or little bit weird feeling. And what is that? What is that brisk effervescence? What is that brisk effervescence? That is of carbon dioxide that you have just taken, right, from the Coke bottle, right? Okay, yes. Now, second application, bacha, second application that you have, second application is of, this is of scuba divers, okay, that is of scuba divers. Yes, second application is of scuba divers. Now, what about scuba divers? What happens to scuba divers, everyone? In scuba diving, what they do? They dive deep into the sea, right? They have their tanks because inside sea, how they will get oxygen? Constant supply of oxygen, they carry tanks with them. In those tanks, oxygen, all these gases are filled. So now what happens, whenever we go, deep into the sea level, like deep into the, core of the earth, right? In that case, what happens here, inside the oceans, the pressure is getting increased, or the pressure is getting increased, okay? Inside sea, what happens? Pressure increases. If pressure increases, solubility is going to increase. And how we are getting oxygen? Because that oxygen, hemoglobin is a component of our body, right? That is in the blood. In blood, we have hemoglobin. In that hemoglobin, that structure is something like this. We have like 4 groups here, right? In between this, there is the affinity of oxygen, right? There is an affinity of oxygen in the hemoglobin group, right? So, the hemoglobin group carries oxygen throughout the body. That means oxygen is dissolved in the blood. So, oxygen is dissolved in the blood. That means there is solubility involved. So, pressure increases, solubility will increase. So, there will be more dissolution of oxygen. That is also dangerous. That you will say, ma'am, we will get more oxygen. But that is more than our body needs. Now, when the scuba divers come out of the sea, on coming out, okay? On coming out, what happens here? The pressure decreases, solubility decreases. Now, when the pressure decreases, the solubility decreases. This means that there will be a condition, a very adverse condition. What is the name of that condition? That is called bends. These are the lines of NCERT. I am not taking this from any other reference. Okay, they will say, ma'am, you are teaching like, I don't know, I have never heard about this. This is exactly in your NCERT that is mentioned. Okay, and you know what is the importance of NCERT in your NEET exam, right? So there is formation of bends. Now what happens? This is actually related to veins. Okay, the problems in the veins. Okay, nerve system, in the vein system, the nerves are getting blocked here, right? So what happens here? Because of bends, that is a situation that leads to damage of bones and muscles, like also inhalation problems. This is a very adverse situation, right? In that situation, to avoid that situation, bacha, what we do to avoid bends, what is added? Everyone, what is added to the tanks? What is added to the tanks? Helium gas is added, nitrogen is added. all these gases are added because they are inert. Right? Nitrogen is also present in our atmosphere, but we do not inhale it because it is inert, right? It has stable configuration. Nitrogen has stable configuration, right? Okay, so helium is a noble gas. It is more inert as compared to nitrogen, right? So these gases are added in the tanks of scuba divers. Okay, this is the second application. Third we have is anoxia. Third we have is anoxia. So everyone know what is anoxia? Now tell me what is anoxia. Everyone here, what is anoxia? What is anoxia? Whenever we go to high temperatures, okay? Whenever we go to high temperatures, high altitudes, okay? High altitudes. High altitudes, pressure decreases, okay? When we are going in high altitudes, right, pressure is decreasing, okay? On going down below the sea level, the pressure increases. Above the sea level, pressure decreases, okay? Here pressure decreases, solubility decreases. So it is very difficult to inhale, right? That is why, okay, this is not, we can say this is the application, this is a thing that happens, that was explained by Henry's law, that why this happens, because pressure decreases, solubility decreases, right? So there is problem of inhaling, right? That is called anoxia, right everyone? Yes, okay, one. Now we have one more thing that we just discussed here, that is, oh my god, now it's gone. Okay, so now there is next thing that we just discussed here, that is everyone, what we just discussed, that is aquatic species are more comfortable in cold water rather than warm water. So anybody, can you answer this? Now talking about all the applications, you have any idea why this occurs? Why we say that aquatic species are more comfortable in cold waters? Why? Because in cold water, temperature is less. Whenever temperature is less, we know that temperature is inversely proportional to solubility. What we have just done here, everyone? What we have done here? Temperature is inversely proportional to solubility, right? So this means that temperature is less. That means that the solubility is more. More is the solubility because aquatic life need gas, right? It need oxygen to, live. So how they get oxygen? They get oxygen from aquatic plants, right? The oxygen is dissolved in the water. Now the dissolved oxygen is carried out by the animals, aquatic animals, right? If the solubility is high, if the solubility of that oxygen in the water is high, that means that oxygen will be available to the aquatic animals also, aquatic life also, except for the plants that are given the oxygen. That is why they are more comfortable in cold water rather than hot water. Yes, everyone? Okay, perfect. Now, these were the applications here. Now, let us see a question on partial pressure on the Henry's law. The partial pressure of ethane over a solution containing this much of ethane is 1 bar. Okay, now what they are saying, just to give students go through this. Okay. I have finished 1 bottle of water, okay, of water. So, in whole summers you will see me like, ma'am, have finished 2 bottles of water while teaching, right? So this is how important is like getting hydrated for me. So now the partial pressure of ethane over a solution containing this of ethane is 1 bar. They are saying the partial pressure is this much. Okay, this is the partial pressure containing this much of ethane. This is the mass of ethane. This is the mass of ethane. If the solution, this is the mass of ethane, write it as M2, right? Okay, if the solution, talking about ethane, will have the value of M2 also. If the solution contains this much of ethane, what shall be the partial pressure of the gas? the partial pressure of ethane over solution is this much for this much. Okay. This is changed here. What shall be the partial pressure of the gas? Just take two things here. Okay, you have they are talking about the same gas, right? Okay, so you have partial pressure is equals to kH into mole fraction. Okay, you can say this is the one, this is the first one. Okay, it is talking about P2 is equals to kH, that is mole fraction of 2, right? Okay, then just divide this 1 by 2. Okay, just divide this 1 by 2. Okay, no issues, no worries. So now we have just divided, this will be P1 by P2 equals to mole fraction of 1 divided by mole fraction of 2, right? So after this, what we are going to see that see this here, okay? What we are going to see here, that partial pressure of 1 divided by 2, okay? This is the partial pressure of second. That is equals to mole fraction of 1 divided by mole fraction of 2. So now after calculating this, everyone, after calculating this, everyone in the comment section, after calculating what will get, this mole fraction of 1 will be equals to P1 by P2 equals to number of moles of 1 divided by N1 plus N2. This is total moles. Let us write it here, total moles. Right? This is number of moles of, this is N2 only when the condition in the second condition. Here 1 and 2 do not represent solute and solvent. Okay, here they do not represent solute or solvent. This is equals to NT. This is cancelled here. This is P1, P2. Right, this N1 will be equals to, that is equals to W1. This is W1 by M1. Now M1 and M2 are same. Why? Because N1 is equals to number of moles. N1 is equals to, this is W1, this is W1, this is M, right? This is the molar mass, okay? This is the molar mass of ethane, right? This is equals to W1 by M and N2 is equals to W2 by M. Because we are talking about solute only. We are not talking about solvent here, right? This 1 and 2 do not represent solute or solvent here. Okay, this will equals to W2, right? Okay, so this is going to be the answer here. Here these 1 and 2, I am writing it here. 1 and 2 represent the first and second condition. Condition means when you have taken this much mass and when you have taken this much mass. Okay, so just put the values of P1 and P2 here. This is the value of P1, right? Contains this much of this is the value of P1. This is the value of P2 that you have to calculate. Okay, calculate P2 equals to P1 into W2 divided by W1. Okay, so just put the values here and you will get the answer. Just put the values here and you will get your answer here. Yes, everyone, just put the values and you will get your answer. Friend, anyone else can say about scuba divers, please? What happened, guys? What happened, Abita? Any problem in that? Yes? Okay, everyone. Now, is this clear to you? How do we calculate this? Right? Okay? Very simple question. Any problem? Shall I move ahead? Okay, bacha. Now see, okay, same question, okay, same thing is applied here, blah, blah, blah. So you have your answer, okay, this is how you have your answer. Right, everyone, right, everyone, right, everyone, okay, tell me. Yes, this is another way of doing this question. You can also do it by what I have said. Yes? Okay. Now, next question is the concept of vapor pressure. So now, what is the concept of vapor pressure here? What is partial vapor pressure? What is pure vapor pressure? Let us understand that. Okay, let us understand these two things here. You have this beaker, okay? You have this beaker, you have another beaker. Here you have component A and this is component B. Right? This is component A, this component B, right? What I am saying that here you have this gas, or you can say that you have this liquid, right? You have this liquid A, you have this liquid B, okay? You have this liquid B. Yes, everyone, you have this liquid B. Wait, okay, you have this liquid B. So, by blue, I am representing the vapor pressure of the vapors that are formed by this liquid A. With pink, I am representing the vapor that are formed by the liquid B. Okay, right? Okay, so this is let us say this is a closed container. Okay, this is a closed container. So now what you see here, the vapor always form pressure, right? The vapors always form pressure here. So what these vapors are going to do here? The vapor pressure that is by the vapors of component A on the liquid A, the vapor that will be, these vapors are going to put pressure here, okay? These vapors are going to put pressures here, right? They are going to put pressure here. So the pressure that is exerted by the vapors of liquid A is called P naught A. Because this A is in the pure state. Here we have not added any other vapors. This vapor pressure, the pressure exerted by the vapors of B component, when B component is in its pure state, okay, the vapor pressure exerted by this one is called P naught B. Yes, bacha. Now let us understand what do you mean by PA and PB. What do you mean by PA and PB? Yes, okay. Yashwant, I have a very sincere concern for you, very serious advice for you, okay? As an elder sister, if you what I'm saying, if you respect me, then I have just one thing for you, right? Okay? That is, if you want to gain something, you have to invest your time here, right? Okay? If you really want to learn something, just give me some time. Okay, very politely I am saying that. I know you are a regular student. I know how important time is for you, right? I don't want to do this. In my mind, why I am going into this much detail? Because I don't want you to, do the chapter like, okay, we are watching this one shot, we will just complete it in 1 hour. Okay, we will have that series. After completing the syllabus, I am going to teach you all the chapters in 1 and 1.5 hours. Okay, I will revise that with you. Don't worry about that. But this chapter now we are doing, this is going to be in detail. Okay, bacha? So that will take time. Okay? Yes, that is my request to you. That is my sincere request to you. Okay? Yes? Okay, chal. Now, beta, we have this beaker. Now here what I am going to do here. Here I am going to add these two liquids. Okay, I am mixing these two liquids here. These two liquids are mixed here. Okay, these two liquids are mixed here, and here I have vapors of A also, right? Here I'll have vapors of A also. I'll have vapors of B also. I'll have vapors of B also, right? Okay, I'll have vapors of B also. I'll have vapors of both these. Okay, and again this is a closed container. Here I'm saying, okay, the vapors are not going away. In this case, what I'm going to write, the vapor pressure that is exerted by, because bacha, if you don't know these things, you won't be able to understand the statement that are asked in your question, in your numericals. Okay, they will not tell you that this is P naught A. They will not tell you that this is P naught B. They don't tell you that this is PA, right? They just give you this statement, and by that statement you yourself have to identify what is P naught A, what is P naught B, what is PA, what is PB, right? For that, this thing is very important, right? So see this, here we say the pressure exerted by the component A, right? The vapors of component A, when they are in the mixture phase, that is called the partial pressure. That is called PA, and the pressure exerted by the component B when they are in the mixture state, that is called PB. Okay, these are the two things. Okay, these are the partial vapor pressure. These are the partial vapor pressures. Okay, these are the partial vapor pressure. Is this clear? Yes, bacha. Very good, very good. So now beta, next thing, okay, next thing, equilibrium condition. They are saying the rate of evaporation is going to be same as rate of condensation. This is what they are saying, that if we say in this case the rate of evaporation, when the rate of the rate at which vapors are getting formed and the rate at which vapors are getting back into liquid, that is going to be same at equilibrium condition. Okay, then the vapors formed will be constant. There will be constant amount of vapors formed. That doesn't mean that liquid is not getting converted into vapors. That just means the liquid that is getting converted into vapors and the vapors that are getting converted into liquids, the rate of vaporization and the condensation is going to be same here. Okay, the rate of vaporization and condensation is equal now. That is when vapors are at constant rate. Yes, perfect. Now let us see, vapor pressure is dependent on what are the factors at which this is dependent. First is the nature of liquid, second is the temperature. What is the nature of liquid? Okay, that depends. If it is the liquid that is volatile, how much volatility it has, right? Some liquids are non-volatile. What is the nature of that thing? Okay, so smaller the intermolecular forces, okay, less are the intermolecular forces. What I am saying here, for example, the intermolecular forces, I am saying there is like the bond is very strong. If the bond is very strong, it will be very difficult to break that bond, and that is how it will be very difficult to form the vapors in that case. Okay, so I'll say vapor pressure is inversely proportional to the intermolecular forces. Right? For example, you have a very good bond with your friend. So now that is very difficult to break the bond. Okay. Similarly, vapor pressure, it is very difficult to break that bond and form the vapors. If the force of attraction is strong, the vapors will be very difficult to form. Right? They are inversely proportional to each other. Right? Okay. Next thing is that at temperature. What about the temperature? For that we have this Clausius-Caprion equation. Right, very important equation. I won't say that questions are asked from this, but yes, you need to know the equation and what is that concept that is involved in this. Okay, numericals are not asked from this, the conceptual questions are asked. Okay, higher temperature, more molecules. They are saying at higher temperature, when the temperature is high, this is the delta HB. This is the enthalpy of vaporization. Okay, now they are saying if you have the temperature is more, if the temperature is more molecules will have enough kinetic energy. More temperature, more kinetic energy to escape from the surface. Right, what I'll say here, more is the temperature, more is the kinetic energy, and more is the vapor formation here. Okay, more is the vapor formation here. Right, and through this you can just write it down here. Vapor formation or vapor pressure you can write. Vapor pressure is directly proportional to the temperature. Right, it is inversely proportional to the forces, intermolecular forces. Right, in a nutshell you can write this thing. Right, okay, what are these clouds that I formed for you? Right, these are the happy clouds. What are these happy clouds? These are the clouds that you need to remember before your exam. Okay, yes, perfect. Means convert in constant ratio. Yes. Now next is is dependent. Vapor pressure does not depend on the it does not depend on the liquid taken, right? Amount of liquid, whatever liquid you have taken, it does not depend on that. It does not depend on the amount of liquid taken. The surface area of liquid, what is the surface area? The volume and shape of the container. Right, very important point. Very important point. That it does not depend on the amount of liquid taken, the surface area of the liquids, and the volume and the shape of the container. Right? Okay, guys. Now let us talk about the Raoult's law. What is Raoult's law? Everyone, what is Raoult's law? So Raoult's law, he calculated. I say that here I am talking about this thing, okay? Here I am talking about this thing. See, this is the pure vapor pressure. This is the vapor pressure. This is called partial vapor pressure. and total of this, if we say P1 plus P2, okay, PA plus P2, PA plus PB equals to the total vapor pressure. This is the total vapor pressure of both the components exerted when they are in the mixture form, when they are in the mixture, right? So he calculated this thing. He calculated this total pressure. How he calculated? How he calculated, everyone? He simply states that one thing that he simply stated this one thing that the pressure, this is the partial vapor pressure. Partial vapor pressure means when A and B are in the mixture form, and together I say when A and B are in mixture form, okay, in this form, this is the partial vapor pressure, right? He said the partial vapor pressure of any component is directly proportional to what? It is directly proportional to the mole fraction, right? Now, ma'am, this is same as Henry's law, isn't it? Yeah, because Henry's law is a special case of Raoult's law, right? This is a special case of Raoult's law. Now I say if I talk about the component A, right? I say PA is directly proportional to mole fraction of A. Then I write, in case of proportionality sign, I write P naught A. That is the pure state vapor pressure. Right? Partial means parts. Okay? Yes. Then what is the difference, ma'am? The difference is that if we talk about Henry's law, I say that this is KH into mole fraction of A. Right? Here I write this, here I write this. This is the difference. We say that Henry's law is the special case. Henry's law is the special case of Raoult's law. This is Raoult's law, this is Henry's law. We say when KH, or we say that when P naught A equals to KH, then we say that is called the Henry's law. Okay, and Henry's law was applied to gases. Okay, that was for gases. And this is what we are talking about here. Okay, in Henry's law, what we said that Henry's law, you have these gases. Okay, you have these gases. We talked about gases here. We are increasing the pressure and here the solubility is increases. This was Henry's law. This was for the gases. But here I am talking about, here I am saying that you have this beaker, you have this liquid, you are mixing that liquid, and here I am saying you have mixed two things here, right? The situations are completely different here. Okay, the situations are different. I am saying you have component A, you have component B, you have mixed it, they have formed the vapors. Now the partial pressure of A component is equals to the pure state partial pressure into the mole fraction, right? Here we are talking about the liquids that form vapors. They were talking about the gases, right? Okay, so Henry's law is nothing but it is the special case of Raoult's law, right? Okay, everyone? Yes. Now I write it here that PA equals to P naught A into mole fraction of A, right? Similarly, I can write PB equals to P naught B mole fraction of B. Now what is PT? What is PT? That is total pressure. What is PT, bacha? This is the total pressure of blue component and pink component. That is A component and B component. That when they are in the mixture, not when they are in the pure state, when they are in the mixture. So I'll write PA plus PB, right? PA plus PB. This equals to P naught A mole fraction of A plus P naught B mole fraction of B. Right? Let us do the derivation. After that, I'll give you a trick that you will write it here. Okay? Yes? Deviation is derivation or deviation. Okay? Right? Now, let us see this. This is PT. Everyone here? Everyone here? Let us write this. Okay, this is PT equals to what you want. Okay, you can do the mole fraction in terms of A or B, right? If I say I want to calculate it in terms of B, okay, I want to calculate it in terms of B. So I'll replace mole fraction of A by, this will be P naught A, 1 minus mole fraction of B, right? Plus P naught B. I'll convert all the mole fraction into one mole fraction, right? This is P naught B, this mole fraction of B, right? Okay. So now what I'll write here, this is PT equals to P naught A plus or minus mole fraction of B, P naught A plus mole fraction of B, P naught B. Right? So this is P naught A plus mole fraction of B, P naught B minus P naught A. Right? This is the end statement of this law, through which questions are asked. Okay? From here questions are asked. Right? The derivation is not important. No. The formula is very important. This formula is very important for NEET. Okay? The derivation is only important for the board exams. Right? Okay? So now let us see this. How do we learn this, ma'am? Simply write Abba. What do you need to remember? Abba. Okay? What do you need to remember? Abba. Okay? Abba. What do you need to remember? Abba. So now what is this? PT, we'll write PT equals to P naught, just write PT is equals to P naught plus mole fraction, P naught minus P naught, right? Similarly write PT, P naught plus mole fraction, P naught minus P naught, right? Okay, in this you just need to replace Abba, okay? Just replace Abba. This was in terms of B, when you have the mole fraction of B. If you want to convert it to mole fraction of A, write B, A, B. Okay, things will be opposite here, right? Okay, yes, very good. Understood this, bacha? Any problem here? Any problem here? Now let us do the next thing here. Now everyone tell me any problem in the Raoult's law. Any problem in the Raoult's law. Any problem in the Raoult's law? So I am feeling very dehydrated. The bottle is now finished. So I have to refill it, right? So now bacha, let us see the, wait. So this is the formula. Okay, we have already done that, right? I would like to write it myself instead of this, right? Okay. So now let us do the formula in terms of, wait. Now let us do the formula in terms of, here what we have done, this was the mole fraction of, this was the mole, this XA, what is this XA everyone? What is this mole fraction? What is this XA? This is a mole fraction of liquid state. This is a mole fraction of liquid component, not the vapors here. What if they have given you the mole fraction of vapors? Now how do you convert it into that? Okay, now if they have given you the mole fraction of vapors, okay, if they have given you the mole fraction of vapors, you need to remember these two formulas. Okay, yes everyone, wait. This is the formula for, this is PB equals to PT. Okay. So what is this now? What is this another formula? Right. Now this YA and YB, these are the mole fraction of these vapors. Okay. You have two mole fractions here. If you are talking about the mole fraction of this liquid part, that is called, see I am writing it here only, okay. If you are talking about this part, that is mole fraction of A. This is mole fraction of B, right? But talking about this part, this part is mole fraction of A, that is represented by Y. This is mole fraction of vapors of B, right? Okay, this is what they are talking about, right? This is what they are talking about, right? Okay, this XA is mole fraction of in liquid state. This is mole fraction, Y is mole fraction is in vapor state, right? Okay, that is the difference here. So just put this formula and see. So these are the, this is just you put the values here, you calculate this, okay. After putting the value, you have XA plus XB is equals to total mole fraction is equals to unity. Now put the values here, all that thing. Okay, for example, what they have done it here, you can just remember this formula also. You can just remember this formula, right? Okay, or you need not remember this formula because this is a basic formula. This is the basic formula. You can generate so many formulas from this, right? So what they have done, they have just converted. They have just, this is equals to that, like you have PA equals to this XA into P not A, right? Here what they have done, you know the value of PA. This is equals to YA. This is PT, right? Okay, then just find the value of XA from here. That is equals to YA PT by P naught A. Okay, just put the value of XP, that is equals to YP PT P naught B, right? Then mole fraction of A plus mole fraction of B equals to unity. Put the values here. You don't need to remember this, okay? You don't need to remember these values. Just put the values here, you will get this formula. Okay? Just put the values here, you will get this formula. Okay? Understood? Do you need to cram this formula? Is this formula worth cramming? Everyone tell me. Is this formula worth cramming? No. You don't need to cram this formula. What's the use of cramming this formula? Right? You just need to remember these two values here. That you have this thing, right? This first formula, right? Then you have one more thing, that is, this is, next you have this one, okay? I'm writing the formulas of Raoult's law here, right? This is Y P A is equals to P naught A mole fraction of A, P B equals to P naught B mole fraction of B, right? You can also write this formula PT. Okay, the formula PT here, that is P naught plus mole fraction P naught minus P naught plus mole fraction P naught minus P naught, and this will be A B B A, right? Or you can say B A A B, right? This is total, right? Or you can say, write it here 1 by PT. This you don't need to remember, but if you want to remember, you can. Okay, 1 by YB, and this is mole fraction. Wait. This is YA plus YB. Even I have not crammed this formula because we know how to form this formula. If you know how to form this formula, you don't need to cram so many things here, right? So this will equals to P naught A, and this is not that much asked question. Now this is not the formula that is so much in use. This formula is in use, this formula is in use, this formula is in use, right? Okay, everyone. So these are the formulas of Raoult's law. Yes? Okay. Now let us do what is Henry's law. Henry's law is a special case of Raoult's law, already done. Yes. Now, bacha, next thing that we have, see, I am writing it here. Raoult's law becomes special case of Henry's law, in which KH becomes equals to this. Okay, in which KH is equals to this, right? Now let us talk about the ideal and non-ideal solutions. Yes, everyone, can you give me just 2 minutes, because I need to refill this, otherwise I will die of dehydration, right? Okay. Okay, everyone, just give me 2 minutes. I'll refill this water bottle. Yes, okay. Okay, or I'll say 5 minutes break, and after that we'll start with the ideal gas solution. Okay, we'll start with the ideal gas here. Okay, ideal gas, non-ideal gas, colligative properties, all those things will be done after in these 2 hours. Okay, the lectures have taken, a long time. I know you will say, ma'am, again, right? Because I want to teach you in detail. I don't want to waste your time in like, okay, we have done everything, like, but I have left so many things. That is not how I teach, right? I want to teach you with proper, like, in detail, so that if you have done this chapter, you should get full marks in this chapter, right? If you do something, do that with proper dedication. Yes? Yes. Okay, everyone. So I'll give you just 5 minutes, right? Take a break. Take the break and relax yourself. Giving you 5 minutes. So yes, I am back, students. I am back. Okay, yes, bacha, I am back, Soumya. Everyone here. Everyone here. Shall we start again? So now, bacha, we have done Raoult's law. Now let us discuss about ideal and non-ideal solution. Ideal solution is that follows Raoult's law. Okay. For example, there are so many rules and regulations. When we follow that, we are ideal person. When we don't follow that, we are non-ideal. So this is which follows Raoult's law. This does not follow Raoult's law. Here we say that delta H mixing, delta V mixing, everything is going to be zero. The interactions of AB and BB is going to be same. That means when we say that students, see here, when we say that this is A and A, this is beaker of B and B, and when we mix it, we have a beaker that has A and B. So when the interactions of A and BB is equals to A and B, right, that means the thing is ideal, that solution is ideal. And for ideal solution, delta V mixing, delta H mixing, everything is going to be same here. Everything is going to be zero here, right? Okay, interactions are going to be zero. Now let us talk about negative and positive deviation. Now here we have two things, okay? With that we have two things. One is ideal, one is negative deviation, other is positive deviation. If we talk about negative deviation, everyone, and we talk about positive deviation, and we talk about positive deviation, right? And we talk about positive deviation. Yes, bacha. So see, this is a solution of A, this is a solution of B, and this is a solution of A and B both. This is a solution of A and B both. This is a solution of A and B both. Now let us see, bacha, if I say that you have negative, if I say that you have positive deviation, in both of these cases, when I say negative, for example, very simple way to understand this, you are sitting alone, right? You are studying, right? You are studying sitting alone, right? That is AA. That is AA. Your friend is sitting alone. He is studying. That is BB. That is BB. Now you and your friends come together in a room and you are studying together. That is a group study. So when you are doing the group study, what happens? Either you are studying more than as comparison to that, or you are studying less, or you are studying in the same manner, right? If you are studying in the same manner, that is called ideal solution. If either when you have group study, you are studying less or more, right? That is positive or negative deviation. So when is positive, when is negative deviation? For example, you have very good interaction with your friends, right? You are just doing chit-chatting and talking about this and that. You are studying less because the interactions are so much. If the interactions are more, in that case, what you will say, the study will be less in this case. If you are chit-chatting more, the study is going to be less in that case. Okay, everyone? Wait, is my voice audible, right? My voice is audible, right? Wait, yes. Okay. So when you are studying more, interactions are less. But when the interactions are more, the study is less. Study less means there is negative impact of those friends, right? Negative impact of those friends on the studies. So here I'll say that A-B interactions are more as compared to AA and BB interactions. That is negative deviation. If I say there is positive deviation, now you don't know each other. Now you guys are literally studying. You here are studying with me. What if here you have your friends from school, right? What you will do? You will chit chat about this and that. You know what happened that day. You know what happened this day. You will just gossip about things, right? Okay. So here you don't know each other. So you are more interested in studying. So here what is happening? This is AA. This is BB. When you are studying alone. Here what is happening? Here we have positive deviation. Here you are studying more, right? Because the interactions between one student and the other student is very less, right? The interactions are less, in that case study is more, right? In that case, studies more, right? So here I'll write that in case of negative deviation, I have delta H mixing, I have delta V mixing. These are less than 0. And in this case, delta H mixing, everyone. In this case, delta, very important, this is okay. Delta V mixing is less than 0. They ask you question from this positive and negative deviation, okay? So now, next, bacha, gossip. Today's kid gossip a lot. I don't know what's they gossip about everything. They gossip about Ambani's wedding also. Okay, why Ambani did that? Why this happened? Why that happened? Why Shah Rukh Khan's son is doing this? Why he is doing this? Why that influencer is doing that? Why this teacher is doing this and that? Right? They take gossip about all these things. That is our human nature. We love all these things, isn't it? Yes. So here we have delta H mixing, delta V mixing less than, wait, this should be greater than 0. Okay, this should be greater than 0. Right? This should be greater than 0. Now, bacha, right? We have written all these things. Now, always remember this one thing, that delta S mixing will always be, everyone, delta S mixing is always going to be more than 0, right? And delta G mixing is always going to be less than 0. Delta S mixing is always going to be more than 0. Delta G mixing is always going to be less than 0. That means delta S is always going to be positive. Delta G is always going to be this. So this Sheikh Samir is saying, you are teaching only for 20 members. Wow. Bacha, yes, I am teaching because I am not that teacher who is like, okay, I have one student, I don't care about that student. Why do I care about that student? I'll teach thousands of students only, I will not teach one student. You know, that teacher is not actually a teacher. All the teachers that right now teach so many students, thousands of students, they must have taught only one student at some point of their life, right? Okay, so at least don't disrespect those teachers. Don't disrespect their struggle. You're not disrespecting me, you are disrespecting their struggle, because you're saying that those teachers' struggle is actually not valuable, right? So always remember this. Yes, okay, we are not here roasters. We are not the people who are here for fame and all that. We want more students, only then I'll teach. No, I'll teach for all the students who trust me, who have trust on me, who are giving their valuable time to me 2 months before the exam, right? Okay? Yes. So now, bacha, we have this delta S, we have delta S mixing always greater than 0, and delta G mixing is always less than 0, always less than 0. No matter it is a negative deviation, no matter it is a positive deviation, it doesn't matter, right? Okay, now, bacha, let us do the graphs here. Graphs are very simple. Okay, see, graph is very simple here. Graph is very simple, bacha. Graph for ideal solution, what you have? For ideal solution, this is, for example, A is 0, right? B is 1. Okay, here A is 1, here B is 0, right? So this is going to be, it has one mole fraction of only B, right? So this is going to be this of B, and this is going to be A. This is going to be A. Okay, wait. This is PT, this is P total, this is PA, this is PB. So, with green I am representing the negative deviation. For negative deviation, this is going to decrease here. This is going to decrease here. For positive deviation, this is going to increase here. Okay, there is so much hodgepodge. With pink I am representing, this line is representing positive deviation. Okay, this is positive deviation. This green one is representing negative deviation, and this blue one is representing ideal situation, right? Okay, yes everyone, yes bacha, Yes. So, bacha, next thing is that the examples here. Very, 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 very important. Very important. Okay. Very important examples. Okay. So, go through all these examples. Bacha, go through all these examples. In positive deviation, what you will see in positive deviation, the interactions will be weakened after this. Okay. For example, A is forming when A individually has hydrogen bonding. For example, water. Okay, let us talk about water here. Okay, water has hydrogen bonding individually with A and A, with water and water molecule had hydrogen bonding. When we mix chloroform with it, the hydrogen bonding is decreased. Then we say interactions are now decreased. Right? Then we say that A-B interactions are weaker as compared to AA interactions. Similarly with ethanol. Ethanol has hydrogen bonding. Now adding CCl4, these hydrogen bonding is going to get decreased here. AB interaction are going to get decreased here. That is why positive deviation here. Right? Now let us talk about this thing. That is negative. These all examples are like that only. Okay, methanol has hydrogen bonding and this methanol has hydrogen bonding. Acetic acid is a dimer form. Okay, it has hydrogen bonding. It has hydrogen bonding here. Both have hydrogen bonding. That is going to get decreased. This has hydrogen bonding. That is going to get decreased here. Okay, that is the main trick to learn these things. Okay, now next thing bacha that we have here is negative deviation. Yes bacha, yes. So negative deviation is what? Negative deviation is, for example, I am saying you have this water and this HCl. Now you have water, right, and you have HCl. What you will see that when water also had hydrogen bonding with its molecule, HCl also had hydrogen bonding with its molecule. But when water is added to HCl, the extent of hydrogen bonding is getting increased here. Right? The extent of hydrogen bonding is getting increased here. That is why we say AB interactions are more. That is why we say here we have negative deviation. Okay, so all these examples are very important for you. There is high chance that they will ask you this question. There is high chance. Okay, yes bacha. On the basis of views we study from where we understand better. Thank you bacha. Thank you so much. Thank you so much. Right, I say all the teachers are valuable because all the teachers are doing their best for you guys, right? Everyone is doing their best for you guys. It's just about understanding. Like it's just about the bonding that you have with that one teacher. Okay, every student, there may be one student who is not understanding by my teaching. Okay, there may be another student who is only able to understand the concept with me, right? Okay, so it just depends on student to student, right? So I think all the two teachers are doing great, right? So you should respect everyone. That is my saying to every student here, because everyone is devoting their time for you, to making things better for you, right? So if you don't want to respect someone, don't disrespect them. Okay, we are not gun pointing you to watch the lecture. You want to watch, most welcome. Okay, most welcome. You don't want to watch, no worries, no worries. Like 3 Idiots, if you have watched that video, if you have watched that movie, that is 3 Idiots. They say Rancho, there was a character Rancho played by Amir Khan. They said knowledge is the uppermost thing. Okay, if you get knowledge from anyone, doesn't matter what's their degree is, doesn't matter. If the knowledge is good, the value is good, that person is adding value to your life, respect that person. That person may be a 2-year-old kid also, right? If that 2-year-old kid is teaching you something, right? So respect that, because they are teaching you something. We learn from students as well. Sometimes students teach us some things like, oh my God, oh really? You know, some motivational things. When I see students who are like, you know, doing hard work and, you know, they motivate us. So we learn from them also. This is what my saying is to all of you. Right? Okay? Yes. Now, let us do the azeotropic mixture. Now, what is azeotropic? There are two types of minimum azeotropic, maximum azeotropic. Just definitions are asked in an examination. Okay? So, now let us see. Binary mixture have same composition in liquid and vapor phase. Okay? Those binary mixture and boils at a constant temperature. those binary mixtures. Okay, I'm not talking about just one thing here. Okay, I'm talking about a mixture. Okay, the mixture is boiling at one constant temperature. Okay, I'm saying that binary mixture which have same composition in liquid as well as in vapor phase. They have the same composition and they boil at the same boiling point. Okay, the temperature is same. They are called azeotropic mixture. Okay, so they cannot be separated by fractional distillation. We have two things here. One is minimum boiling azeotrope. Next is maximum boiling azeotrope. Minimum boiling azeotrope is something when you say that it is showing positive deviation, the interactions are less. This means that mixture whose boiling point is less than either of the two pure components. Why the boiling point is less, everyone? Why the boiling point is less? Because in positive deviation, AB interactions are less. Okay, AB interactions are less. So to break those interactions, less boiling, less temperature is needed. Okay, so what happened? You have AA mixture, you have BB mixture. Okay, you have BB mixture. So AB mixture, the interactions are weak as compared to AA and BB. That's why less boiling point is needed. That's why less temperature is needed, right? And that is why we say boiling point is less than either of the two pure components. That means this is shown by positive deviation only, right? Okay, for example, all the cases where we have positive deviation, right? Okay, next beta here, percentage is also important for you, right? Okay, percentage is also important for you. So do these two examples here. Do these two examples here. Now, bacha, maximum azeotropic mixture, maximum boiling azeotrope is that which is showing negative deviation. That means A-B interactions are more boiling point is needed here. Okay, that means we'll say more than either of this. Boiling point is more. How do you remember this? Maximum negative. Just remember this. Okay. Okay. So most of this world is filled with negativity. There are just few persons who are filled with positivity. So try to encounter with those positive souls and make them friends. So this is how you remember this. Maximum, most of this world is filled with negativity. Right? Okay? Yes? Okay. Now, next thing is, bacha, let us do the question here. The question here says that heptane and octane from an ideal solution. Okay? Heptane and octane form an ideal solution. They form an ideal solution. Okay, ma'am, perfect. From an ideal solution at 373 Kelvin. I say at 373 Kelvin. The vapor pressure of the two liquid components. We have two liquid components are this and this. Okay, these are the vapor pressure. Okay. Heptane and octane are ideal solutions. At this, the vapor pressure. They are saying vapor pressures. They are talking about, bacha, what they are talking? They are talking here. They are talking about, this is the vapor pressure of, respectively means they are talking about the vapor pressure of two liquids. That is heptane. This is the vapor pressure of heptane. This is the vapor pressure of heptane. Vapor pressure of heptane. You can say P of heptane. This is the vapor pressure of octane, PC, PO. What will be the vapor pressure of the mixture? That means they are talking about PT of this much of heptane, this much of octane, right? Okay. Wait, this is the vapor pressure of two liquid components are this and this respectively. So they are talking about P naught. They are talking about P naught. Okay. They are talking about P naught and this is also P naught O. Right? They are talking about P naught H and P naught O. That means they are talking about pure state vapor pressure. They are not talking about the partial vapor pressure. They are talking about the vapor pressure of these two components in the pure state. So how do you answer this? PT is equals to P naught A or P naught H of heptane, mole fraction of heptane plus pure vapor pressure or vapor pressure of octane, mole fraction of octane. Now the mass is given to you. That means M of heptane, mass of, or you can say W of heptane W of octane is given to you. We can write it here, right? Okay. Or you can also, after this, how you calculate this? Firstly, calculate the number of moles of heptane, that is number of moles of heptane plus number of moles of octane plus number of moles of heptane, right? Then calculate the number of moles of octane, that is number of moles of, then calculate the mole fraction. Wait, let us write it here, mole fraction. This is mole fraction of octane, number of moles of octane plus divided by number of moles of octane, number of moles of heptane, right? These are the total number of moles. Fill the values here, okay? This is also given to you, everyone. Now, what is the value for this one? What is the value of NH? NH is equals to weight of heptane divided by molar mass of heptane. NO is equals to weight of octane divided by molar mass of octane. You know the value of everything. You can calculate the molar mass of octane, molar mass of heptane. W is given to you, right? You will calculate the number of moles of heptane and octane. Put the values here. You will get the mole fraction of heptane and octane. Put the values here. Pure state vapor pressure is given to you for heptane and octane. This is how you will get the value for total vapor pressure. Yes, everyone, any problem in this? You have just applied the Raoult law here, right? Okay, just calculate it and you will get your answer. Okay. Now, let us see 2019 question. 2019 question that is asked, in water saturated, they are saying in water saturated air, the mole fraction of water vapor. Water saturated air, that means you have water vapors of, you have water vapors in that air, right? The mole fraction of water vapor is this. You have mole fraction of water vapor. Mole fraction of water vapor is equals to 0.02. Okay, the total pressure of the saturated air, the total pressure of the saturated air is equals to 1.2. Okay, the partial pressure of the dry air is equals to, see, what is the total vapor pressure? Dry vapor pressure plus moist vapor pressure, right? So let us calculate the moist vapor pressure, the pressure of moist vapor, like the pressure of moist air, right? You calculate the pressure of moist air, right? Then you add these two, this will be equals to total pressure is equals to dry air plus pressure of moist air, right? Okay, so how you calculate the pressure of moist air? You will calculate from these things that are given to you, right? Okay, bacha, so now let us see this. Okay, so firstly, water vapor, see, this is the thing here, total pressure is equals to water vapor plus dry, okay, moist air plus dry air. So now this is given to you, this you have to find out, and this you will find out by the things that are given to you, that is water vapor pressure. What is that? Equals to mole fraction of water vapor, that is given to you into total pressure. Now ma'am, what is this formula? Do you remember this formula? Given by Dalton's, that says that the pressure, you can say the partial pressure, you can say, okay, of water, or you can say moist air, or water vapors, that is equals to Y. What is this Y? I'll write it here, Y, okay. Why? Because Y is the mole fraction of the vapors, not the liquid component, right? Okay, so this is the mole fraction of vapors, right? Okay, water vapors, Vp I am saying, here I am writing Vp, Wp, Wv, right? Mole fraction of moist air into, we have total pressure, right? Have we done this thing? This was given by Dalton's, right? Right? That was in terms of mole fraction of the gas, mole fraction of the vapors, right? Okay, you calculate the pressure of vapor pressure, right? Then you add Pt is equals to Pwp, that is vapor pressure, plus add on this to dry air, and you will get the value of dry air from here. Okay? Yes, bacha? Okay, students? Understood this? Yes, that was easy. That was, ma'am, easy. Now 2020 question, just 3 years back this question was asked. The mixture that which shows positive deviation from Raoult's law. Everyone, which shows positive deviation from Raoult's law? Okay, why everyone here wants to get blocked from me? Oh God, oh God. Why beta, why? Okay. Now everyone, just tell me this thing. Yes, the mixture which shows positive deviation from Raoult's law. Which shows positive deviation from Raoult's law, ethanol or this? Positive deviation means A-B interactions are less. Okay, A-B interaction should be less here. Okay, A-B interaction should be less here. This is ideal solution. This is talking about ethanol, acetone and chloroform. Less interactions we need. Chloroethane, bromoethane. So the answer here comes out to be ethanol and acetone. Okay, ethanol and acetone. It has hydrogen bonding. It has hydrogen bonding. After adding acetone, that is CH3, C double bond O, CH3. So here the hydrogen bonding is going to get decreased in this case. So A is going to be the right answer here. Okay, A is going to be the right answer here. Now, bacha, let us see the next question, that is 2019 question. See, regularly they are asking you, continuously question are based on the examples of positive and negative deviation. The mixture that forms maximum boiling azeotrope, okay, maximum boiling azeotrope, everyone, that needs more boiling point to break the AB interactions. That means the AB interactions are more, and when the AB interactions are more, we say it is a negative deviation. We say it is a negative deviation. So what they are asking you? They are asking you about the negative deviation here. So what is the negative deviation here, everyone? What is the negative deviation here? Yes. So you have this acetone and carbon dioxide. Everyone, this is acetone and carbon dioxide. Then you have this two, this ethanol and water. Water and nitric acid. Water and nitric acid. Very good. Very good. Okay, so the answer is going to be water and nitric acid. We have done this example just now. Okay. Yes, everyone. Water, because it has hydrogen bonds. This will also, this is HNO3, right? HNO3 is going to get increased. The AB bonds are going to be more interactive because the water will have more strong bonding, more strong hydrogen bonding with HNO3, right? Okay, yes. So negative deviation from this, the mixture shows negative deviation, right? This mixture shows negative deviation. Now let us talk about the colligative properties. Now everyone, till now, is everything clear to all of you? Is everything clear to bacha? Is everything clear to all of you students? Any problem till now? Any problem? Any problem? Any problem, bacho? Yes? Okay. We have completed like just like 1/4 part of this chapter is left, which is like the most important part. But if you don't know the before part, you won't be able to understand this part, right? Okay, very simple chapter. Colligative properties are also very simple. Okay, yes, bacha, yes. Okay, now we are going to see what are colligative properties. These are those properties that are dependent on the number of particles of solute. How much solute you have added, right? Always I will take a non-volatile solute here. Always I will take non-volatile solute. Okay. Here we are going to take non-volatile solute. We are not going to take volatile solute. For that we have Raoult's law. Okay, where both of them were forming vapors. Here we will add a non-volatile solute. Okay, so before getting into the colligative properties, I'll tell you some things here. Okay, just few things, and colligative property will be a task of 1 minute for you. Right? Okay, let us see that. Okay, let us see that. So we talk about 3 things mainly, that is vapor pressure, boiling point, freezing point, and fourth is osmotic pressure. Right? These things I'll teach you here, and osmotic pressure I'll teach you like after this. Okay? Yes? Now, firstly tell me you have this beaker. You have this beaker. Now, you have in this beaker, you have a solvent. Okay, bacha, you have a solvent. Now, what I am doing, I am adding a non-volatile solute that is not forming any vapors. Okay, only this solvent is forming vapors here. Earlier, it was forming this much vapors. Oh my God, it is forming so much vapors here. Okay, why? Because there is no restriction. There is no restriction. When there is no restriction, you will say, okay, I'll use Instagram whole day. I'll watch Netflix whole day. But now you have exams. You will say, I can't watch that. I don't have time. Right? When you have non-volatile solute, there are restrictions. Okay, there are restrictions. You will say, oh my God, now what should I do? Now, the screen time is going to get decreased here. Right? Why? Because the solute particles, we have added the solute particles in this. Okay, we have added the solute particles in this. They will, okay, there is, for example, there is a room full of there is a room full of what kind of, okay, there is a room full of students. Okay, there is a room full of students. Okay, so students are like, okay, we are doing masti, we are doing fun, okay, we are just chit chatting and all that. Now teacher come. Okay, when the teacher came, what happened? Teacher came and students were like, oh my God, teacher is there. Okay, let's be quiet. Okay, let's be quiet. They're like sitting quiet. Okay, check. So now what happened? There are restrictions because 2-3 teachers, if they're coming, right, in one class, what they will do? They will restrict the students to form vapors, to get expand, to dance in the class, right? So that will be restricted. Now this is what you do in the recess time, is it? You do this in the break time, right? You dance and roam here and there. But the teacher will restrict that. So the teacher here is that non-volatile solute. Okay. So on adding the non-volatile solute, everyone, on adding the non-volatile solute, first thing that I am going to write here is, first thing is vapor pressure decreases. Okay. Vapor pressure of solvent decreases. This decreases. Now let us talk about the boiling point, right? Let us talk about the boiling point. Now what is boiling point? Boiling point is nothing but it is when you have, for example, when the vapor pressure of any liquid is equals to the vapor pressure of the atmosphere. Or you can say the atmospheric pressure. Right? For example, this is the vapor pressure of liquid. And giving it temperature, it is forming more vapors, more vapors, more vapors, more vapors. At one point, this is equals to the atmospheric pressure. I'll say now it has achieved boiling point. Right? Okay? This is the definition of boiling point. Now you know that, for example, I'm drawing it for you here. Okay? This is the atmospheric pressure. Right? This is the atmospheric pressure. Atmospheric pressure. Now I'll say this one thing, this is the solute, this is the solvent. White is represented by, white represents solvent, this represents solvent, and this pink represents solute, which is non-volatile, right, which is non-volatile. So what will happen here? What will happen here, bacha? Vapor pressure is going to get decreased. Okay, this is vapor pressure of, this is vapor pressure of solvent, right? And here, when I added the solute, the vapor pressure of the solution is going to get decreased here. So I'll write, this is the vapor pressure of solution. This is the vapor pressure of solution. Earlier, this was the jump that was needed. This was the boiling point when there is no solute, right? That is TB naught. But now the jump is this much. Okay, this is the boiling point when we added the solute. That means boiling point has increased. How I say that? Okay, please ma'am. Yes, okay, bacha, definitely. After that, I am going to do chemical kinetics and electrochemistry. Firstly, let me complete physical chemistry. Okay. Yes. So bacha, this is the atmospheric pressure, this is the I say this is the vapor pressure. Okay, this was the vapor pressure of solvent. Earlier this was the jump that was needed, this was the boiling point, right? But now we have decreased the boiling point. Now it has to jump this much. Okay, this is the jump that is needed. That means boiling point has increased. That is the elevation of boiling point. Now everybody, what I'll write here, this is the elevation of boiling point. Okay, elevation of boiling point. Vapor pressure decreases, boiling point increases. Right, boiling point increases here. Tell me students, any problem? Any problem in understanding this? Any problem in understanding this part? Yes, everyone? Everyone here? Are you clear on this? Yes? So now let us see what is freezing point. Now bacha, let us see what is freezing point. Freezing point is when something is getting freezed, right? Something is getting freezed. So in that case, vapor pressure should be equal to the vapor pressure of solid. I'm also writing it here. Boiling point in simple terms is, boiling point is when vapor pressure equals to atmospheric pressure, right? Okay, and what is freezing point? Freezing point is that when we say vapor pressure equals to what? The vapor pressure of solid, of that solid component, of the solid component, right? That means which is less. The vapor pressure of solid component, something is getting freezed, so the vapor pressure will decrease because the ability to form vapor is going to get decreased here, right? Okay, so what I'll write, this is the vapor pressure of solid. Okay, this is the vapor pressure of solid. I say that this is the vapor pressure of this solvent. This is the vapor pressure of when this solvent is in the solid state, right? When this solvent is in the solid state. Here I say we have the vapor pressure of solvent, right? The vapor pressure should be equal to vapor pressure of solid, of the solid component. That means it is going to lower the temperature. The less the temperature, we decrease the vapor pressure. The vapor pressure will decrease and it will be equal to the vapor pressure of solid. Here the vapor pressure need to get decreased. Okay, the vapor pressure should decrease and it will be equals to vapor pressure of solid. Now what I do after, see this is the vapor pressure of solvent. When I added the non-volatile solute, the vapor pressure get to this much. Now vapor pressure decreases. Now what I say, the vapor pressure of solution decreases. That we already know from this side. Okay, vapor pressure of solution decreases. When vapor pressure of solution decreases, what I say, now the jump is less. Earlier this was the jump that was needed. Wait. Vapor pressure is less. Oh, now the jump is less. Right. Okay, earlier this was the jump that was needed. Yes, this was the jump that was needed. This was the vapor pressure of solvent. Now solvent on adding solute, vapor pressure decreases. Now this is the jump because vapor pressure of solid will remain same. Yes, students. Okay. Yes. So now you have, this is the vapor pressure of solid. This is the vapor pressure of solid. This is the vapor pressure of. This is the vapor pressure of. This is the vapor pressure, everyone. This is the vapor pressure of solvent. Right? And I see this is the vapor pressure of solution. Now vapor pressure of solution decreases. Vapor pressure of solution. Earlier the jump was this much. This was the jump that was needed. This was TF naught. And now the jump is less. Now we have TF. Right? Now we have TF. Right? That means everyone. What does this mean, everyone? This is the depression in freezing point. So I'll write it here that we have depression in freezing point. The freezing point decreases. right? Okay, any problem here everyone? Yes, no worries Mithali, thank you so much beta, thank you so much, no worries, even my grammar is not so good, so relax. Okay, we are here to teach science and chemistry. We don't care about grammar, we are not doing literature, right? Okay, yes, so this is the thing. Everyone, is this clear to all of you? Yes everyone, it's little confusing. Now is this clear? So what happens here everyone? We are adding the vapor pressure. We are adding the non-volatile solute. On adding the non-volatile solute, vapor pressure decreases. So when vapor pressure decreases, a solution, this is a solute, this is a solvent, this is a solution. This is a solvent, this is a solution. In both the cases, because of decrease in vapor pressure, boiling point increases. Because what is the definition of boiling point? That vapor pressure equals to atmospheric pressure. And atmospheric pressure jump is more here. But according to the freezing point is vapor pressure equals to vapor pressure of solid components. So when vapor pressure of this is vapor pressure of solid component, this is the solvent. So here the jump is high, here the jump is less. Right? Okay everyone, that is why what we say here TB is more than TB naught, right? And here TF naught is more than TF. Right? Okay everyone? Yes. Okay, perfect, perfect. Now let us do the next thing, that is colligative property. This is relative lowering. So this is nothing but decrease in vapor pressure, elevation, nothing but increase in boiling point, and this is nothing but decrease in the freezing point, right? This is decrease in the freezing point, depression in freezing point, and we'll do the osmotic pressure after this. Okay, I'll do the osmotic pressure in detail, don't worry. Okay, this is the first, second, third and fourth colligative properties. So these are the 4 colligative properties that are very, very important for you, right? This is a lowering in vapor pressure, right? Then we have, what is the formula? Now derivations are not important for you, right? Derivations are not important for you. This is the same derivation from the Raoult law. You will get the values here. From the Raoult law, you will get the values here. Okay, so now let us see the value. Okay, I'll write my own formulas, which I'll write my own formulas. Instead of this, I'll write my own formulas, okay? I'm deleting this because otherwise it is going to get very confusing for you, right? It is going to get very confusing for you if you get, if you get stuck in writing the formulas, right? I'll write the simple formula here, that is P naught minus P. My own formulas doesn't mean I have derived these formulas, these are the same formulas. It's just that the denotation of A and B and 1 and 2 confuses a lot of students, right? So what I told you, that 2 is always for solute, 1 is always for solution, solvent, right? So that is equals to the mole fraction of solute. That means we are talking about solute here. This is the first colligative property, right? This is the first colligative property. This is relative lowering in. This is relative lowering in vapor pressure. Right, this is relative lowering in vapor pressure. Yes, students, is this clear to all? Now, this thing is lowering in vapor pressure. Lowering in vapor pressure. If they ask you what is the value of lowering in vapor pressure, write the value P naught. Lowering in vapor pressure will be P naught minus P is equals to this. Right? This is the lowering in vapor pressure. You have to calculate the value of this term. If they ask you what is relative lowering in vapor pressure, calculate this whole term. If they ask you what is the vapor pressure, calculate P naught. If they ask you what is the partial vapor pressure, calculate this P. Okay, that is equals to mole fraction of solute. Okay, that is equals to mole fraction of solute. And this is the first formula. Second formula, students. Second formula that we have, everyone, second formula that we have, that is for temperature, that is for, wait, I'm writing the formulas for colligative properties here, right? This is the first colligative property, this is the second colligative property, this is the first colligative property. The second colligative property is delta TB equals to molality into Kb. Okay, this is Lebesgue constant or molar elevation constant. Okay, this is molar elevation constant or Lebescopic constant. This is the name that is given to this Kb, right? That is constant, that is always given to in the question. You have to learn it for water, right? Always learn it for water, right? Molality, this is M is molality. This is also known as Tb, because this is elevation. So Tb minus Tb naught. More will be the thing that because there is elevation in boiling point, so here will be more minus less always. So more is Tb, less minus Tb naught, right? More minus less, because Tb is more than Tb naught, right? That's why I have written Tb minus Tb naught. And this is equals to molality. Molality, what is molality, bacha? This is W2 by M2 into W1 into 1000, right? Because everything is in grams, and this is the thing that you have to learn, right? But you don't need to learn this formula. Just learn this formula, okay? Everything else you can just put the values here, right? Okay, you know the value of molality, you know the value of delta Tb, right? Okay, the third formula that we have is depression in freezing point. Depression in freezing point is delta Tf equals to same molality into Kf. This Kf is cryoscopic constant, okay? It's crying, okay? It's cryoscopic constant because it is made you cry, it will have to cry also, right? So it is cryoscopic constant, also called molar depression constant. Molar for molality, molar depression constant. So we can write this as Tf naught minus Tf, because there is depression. So here we have Tf naught is more than Tf. So more will be less amount will be always this subtraction of, because temperature is like temperature, we are calculating the change here. To calculate the change, we say more minus less. The more values of delta T naught. So delta T naught, I'm saying Tf naught minus Tf equals to delta Tf, right? Okay, so this is equals to W2 by M2 into W1 into 1000 into what we are saying? Into 1000, okay, into 1000, right? My OCD for blackboard. Do you all know my OCD for blackboard? How much you know your teacher? Are you all aware of my OCD for blackboard? Yes or not? If you're not aware, you will observe this thing. What I do, if I have written something like this, okay, if I am writing like this, okay, for example, if I am writing A, now this is a very good writing. For example, I am writing B now here, okay, so I'll get very irritated by this. What I'll do, I'll erase this. Now if I see this kind of thing, I'll also erase this. After that, I'll erase everything and write it again. So this is my OCD for blackboard. So next thing is fourth is you know what, how much I control myself. Now I have written this fourth here. What I do, I erase it and I try to write it here. No, this is not good. I'll try to write it at the perfect position that I can write. Oh God, I am so sick and tired of this, right? So now bacha, next thing is osmotic pressure. Now let us see what is osmotic pressure, everyone. Firstly, let us see what is osmotic pressure, then we will fill this plan. Okay, just fill this now. Okay, this is PV is equals to nRT. You all know that what is equals to PV is equals to nRT. P is nothing but pressure. Okay, just in place of P, write here pi. Okay, write pi here. Okay, this pi is osmotic pressure. I will teach you. Don't worry. Okay, all the theories will be covered here. This will be pi is equals to PV equals to nRT. Right? This means pi is equals to n by V RT. This means this n by V, bacha, what is this n by V? We all know that one thing. That thing what you know, that ma'am, number of moles by volume is equals to molarity. We can say capital M, or we can write where I'll write C. That is molarity RT. Okay, so I'll write one thing in all these things, that this is relative lowering in vapor pressure is dependent on mole fraction, right? This is dependent on molality. This is dependent on molality. This is dependent on molarity. This is molarity. Okay? Yes, everyone? Okay? Yes, everyone? Mole fraction, molality, molality, molarity. Okay, this is the use of concentration terms in these colligative properties. If you know how to calculate the concentration term, these numerical will be a piece of cake for you. Right? Okay? So now, next thing is, let us study this graph. Okay, let us study this graph. Okay, let us study the graph for elevation and boiling point. So what does this graph means? This graph, bacha, are you able to see this graph? So this graph simply means that you have this solvent. Okay, this is the temperature, is the vapor pressure. Earlier it had this much vapor pressure. Okay, that the thing that I draw for you, that was, this is the vapor pressure of solvent. You decrease, this is a vapor pressure of solution. Similarly, what they have done in this way, this is a vapor pressure of solvent, this is a vapor pressure of solution, right? Okay, this is a vapor pressure of solvent, this is vapor pressure of solution. Vapor pressure is like with decreasing temperature, you are decreasing the temperature, lesser will be the vapors. Like less temperature, less vapors will be formed. That is why there is this kind of curve here. Okay, so now they said that what is the boiling point? Boiling point is that point at which vapor pressure of the solvent is equals to 1 atmosphere, that is osmotic pressure. Right? So now this is going to be very easy for you to study this graph. Okay, now vapor pressure should be equals to the atmospheric pressure. That means this is the boiling point here. Right? This is the boiling point here. Now after this, what I am saying, that the vapor pressure is decreased. The vapor pressure is decreased. Now this is going to be a new curve. This is going to be a new curve for solution. Right? Now, vapor pressure equals to atmospheric pressure is your boiling point. That means this point is your boiling point. And this point is going to be your boiling point. This is your boiling point. Right? And here, this is your boiling point. Here, this is your boiling point. Right, everyone? So, this is nothing but this is TB naught and this is TB. Yes, everyone? Okay. Understood? This is the graph for elevation and boiling point. Everything we have done here, everything we have done, this is also done. Right, now this formula, there are very less chances that they are going to ask you this formula, very less chances, but still you should know this formula. No numerical will be asked from this formula, but they can ask you some conceptual question like alebbioscopic constant is inversely proportional to the enthalpy of vaporization. They can ask you questions like this. Alebbioscopic constant is directly proportional to the boiling point. Alebbioscopic constant is, what is the formula? Okay, they can ask you about the enthalpy of vaporization, that is inversely proportional. Okay, so this formula you should know. Okay, yes, very less chances, but they can ask you some conceptual question based on this. Right, next is depression in freezing point. There is decrease in the freezing point. Yes, we have done this. Now let us see the graph here. Let us study the graph, everyone. Let us study the graph here. Okay, this is the graph. Now what does this graph states? This graph states that you have this curve, that is you have this liquid solvent. Okay, you have this liquid solvent. This is the liquid solvent that you have. Right, we say freezing point is that when the vapor pressure of that solvent is equals to solid. Okay, here the vapor pressure of solvent is equal to the vapor pressure of solid. That is your freezing point. Okay, that is your freezing point. That is your freezing point now. They said, now after this is a frozen solvent. Okay, this is the frozen solvent. This is the frozen solvent. Right, because here it is getting dissolved. It is now in the freezing state. Right, so now you have this solution. Solution is nothing but you have added the solute component to it. When you have added the solute component, what is going to happen, bacha? What is going to happen? Now this curve with the vapor pressure is going to decrease here. Vapor pressure is going to decrease here. Now when you have this vapor pressure is equals to the solid component. What is the solid component, bacha? This is the solid component. This is the solid component. This is the solid component. Earlier, now this liquid is in contact with this, matches the solid component here, right? But now the liquid component, so the solution component matches the solid component here. This is the freezing point, right? Okay, this is the same thing that I was telling you. That freezing point is nothing but when vapor pressure is equals to the vapor pressure of that solvent, right? Okay, so this is the vapor pressure. This blue represents the vapor pressure of solvent. The vapor pressure of the vapor pressure of solid state, right? So when this liquid is equals to vapor pressure of solid state, that is freezing point at pure state when there is no solute, right? But this is solution. Now this is decreased, right? This is the delta TB. This is the delta TF. Sorry, this is the delta TF. Yes, everyone. Okay. Okay, all the best, Sharath. I know you will rock, you will do your best, and all my wishes are with you. Just don't panic. Now take rest and revise everything. All the best, much love, much blessings for you and all the students who have exams, right? All my blessings are with you. Just be relaxed, okay? You have studied well, you have done your hard work. Now just leave it upon the good. Surrender yourself now. Yes, everyone, all the best. Everyone, all the best to all the students who are right now giving their board exams. Okay? Yes. So now, next thing that we have, this is the formula. Again, now this is cryoscopic constant that is inversely proportional to the enthalpy of fusion. Thank you. But all the best. Badhiya. Very nice. So now next thing bacha that we have is the applications of this. Okay, applications. First is anti-freezer solution. When we want to anti-freeze, when we don't want to freeze something, what we will do? Okay, to avoid freezing of water in the radiators used in car, anti-freezer are added so that freezing point of water is depressed. The freezing point, to lower down the freezing point, the non-volatile solute is added to it. Okay, that is actually good for the radiators. We cannot add NaCl to that, okay, because that should be something that we can use in the radiators. Okay, so to do the anti-freezing things, we add the anti-freezer in the car radiators. Okay, yes, bacha. Second thing is, now where there is so much snow in countries that have like there is winter season, there's less than like 20-30 degree temperature. For that, living under those conditions is very tough, right? So what they do, they actually they pour the solute, that is NaCl, into the water so that the freezing point decreases. When the freezing point decreases, for example, earlier the freezing point, for example, let us say that is 0 degree. Okay, if we add the non-volatile solute, let us say on adding non-volatile solute, it becomes a minus 97 or minus 98, something like that, any amount less than 0 degrees Celsius. So now the freezing point decreases. That means we can save that thing for getting depressed. Okay, this much is not actually the delta TF. That is usually in points. Okay, that is usually very less. Okay, yes, everyone. So we add non-volatile solute to decrease the freezing point in the real life situations. Yes, everyone. Okay. Yes, that's true. That's true, aimless. That is true. Yes. Okay. So now next is 2016 question. At 100 degrees Celsius, the vapor pressure of solution. Right? At 100 degrees Celsius, the vapor pressure. Everybody answer this question. Okay? Answer this question. Everyone here, answer this question. What is this answer? What is the answer? Now you have at 100 degrees Celsius, the vapor pressure of solution. This is kb. That means this is a question of elevation, right? At 100 degrees Celsius, the vapor pressure of the solution of this much of a solute is this much in this. Okay. If kb is this, the boiling point of this will be. Okay. They are asking you the boiling point of this solution. That means they are asking you TB minus TB naught equals to Kb into molality. Right? Okay, if the vapor pressure of the solution of this much of a solute is 100 grams. Wait. My eyes are getting, little because of this screen timing, na? Okay, just wait. I need to relax my eyes. Just wait. Okay. So at 100 degrees Celsius, the vapor pressure of solution, they are saying the vapor pressure of solution of the 6 point this of a solute. This is the solute. That means they have given you W2. Right? Okay. In 100 gram water, that means this is W1. Okay. Is this much. Okay. W2 is given to you. Solute is not given to you. M1 is not given to you. Right? Okay. M1 is not given to you. So what you will do from this side, you will calculate the value of M1. Okay. You will calculate the value of M1. Right? And then you will put the value of M1 to calculate the molality. Now, the boiling point, this is 100. This is already 100 because boiling point of water is 100 degrees Celsius. You will have to calculate this one. This is already constant, right? This is already, that the value is this much. This is already given to you. You have to calculate this molality. Even in this molality, you just have to calculate the solute. What is the solute here? Right? That is the number of moles here. Right? This is just that you have to calculate here. Right? Now let us see this. Okay, for example, this is the PS, that is the total pressure, right? This is Kb and this is. See, just apply this formula. Okay, apply this formula here, that is relative lowering of vapor pressure, right? You know that what is the expected vapor pressure? Expected vapor pressure is 760. That is your atmospheric pressure, right? 760. 760 minus 732 divided by 760, that P naught, that is your pressure is 760 mm of Hg, right? This is your given, that is pressure that is given to you into N2. So to calculate the value of N2 from this, you calculate the value of N2 from here, then put the value of N2 in this. Just put the molarity is equals to N2 divided by W1 into 1000. Okay, just put the value of N2 to this, right? And you will have your value. Right, everyone? Okay. Yes, everyone? Oh my God. Don't worry. Okay, this is valuable screen time. Yes? Okay? Yes, bacha? Any problem here? Or should I solve it? Bacha, see this, very simple. You just have to calculate the value of molality. What is molality? In molality, what you have? In molality, you have W2 divided by M1 into, or I can write this, see, you have TB minus TB naught equals to Kb into W2 divided by M2 into M1 into W1 into 1000, right? In this, you have everything here, right? You have the value of TB naught, that is 100 degree. You have the value of Kb. You have the value of W1. You have the value of W2. You just don't have the value of M2 here. Okay. So for that, what they have given you this one hint, that P naught minus P divided by P naught equals to mole fraction of 2. Mole fraction of 2 is nothing but N2 by N1. So now what is N1? N1 is given to you, right? N1 is given to you. So what is this N1? N1 is 100 gram of water. That means this is 100 gram of water. Water means this is the molar mass of water. This is N2. You can calculate the value of W1. You can calculate the value of N2 and put into this. Okay, you can calculate the value of W1 also. You can calculate the value of N2 and put into this. Okay, put the value of N2 here. This is N2, right? Calculate the value of N2 from here. Okay, just very simple. This is 760 minus what is given to you here, 732, right, divided by 760. This is atmospheric pressure. Let's calculate the value of N2 and put the value of N2 here, right? Put the value of N2 here, right? So put the value of N2 here. So this is TB minus 100. 100 is the boiling point. What is the boiling point of water? 100 degrees Celsius, right? This is 0.52, right? Into N2 is, you will calculate, right? Okay, to make calculations easy. So just calculate the value of TB, right? Okay, Ma'am, doubt. Yes, bacha asked me, what is the doubt here? What is the doubt? What is the doubt, everyone? What happened? Yes, I am here only. Ask the doubt. Yes, bacho. Yes, bacho. What is the doubt? After that, we are going to do osmosis. Let us do osmosis. Let us do osmosis. Right, again, I am drawing this beaker here. Okay, let us select the beaker from the tools. Okay, let us do something like interesting. Which is this? Subject, teaching, okay, chemistry. What is the semi-permeable? With a semi-permeable membrane I need. Okay, with a semi-permeable membrane I need. You're liking anything here? Oh my god. Ayyo. Just relax for some time. You should relax in between, okay? We don't want to waste even 1 minute. Okay, don't worry. We are already studying so much. Right? Okay, let us draw this. This is the semi-permeable membrane. We'll make the semi-permeable membrane out of this tub. Okay. Oh, this is also increasing, decreasing. Wow. This is amazing. Okay. I like it. I really like it. So, this is your beaker. And now what I am doing, I am making a semi-permeable membrane in this. Okay. But I won't be able to teach. Because drawing it myself is more fun now, right? Okay, I'll draw it myself, don't worry, I'll draw it myself because selecting that takes a lot of time, right? So this is the semi-permeable membrane. Now what is the function of this semi-permeable membrane, everyone? What is the function of this semi-permeable membrane? It allows only VIPs. What are those VIPs? It allows only solute particles. Okay, the particles that are only solvent particles, because solvent particles are less in size. The size of solute particles is large as compared to solvent particles. So it will allow only the solute particles. Now let us say the concentration is this much here, the concentration is this much. Okay, we know that pressure is P is directly proportional to, we know PV is equals to nRT, right? That means P is equals to CRT. That C is called the molarity. That means pressure is directly proportional to the concentrations. Okay, so now if I want to calculate what is the difference between, we just write it here, pressure is directly proportional to the concentration. If I say what is osmosis, diffusion and osmosis, difference between osmosis and diffusion. Diffusion is nothing, that is the movement of particles from higher concentration to lower concentration for anything. That is the movement of particles from higher concentration to lower concentration, any particle. But osmosis is the movement of, osmosis is movement of solvent particles from higher to lower. Okay, that is the movement of only the solvent particles, not the solute particles. Not the solute particles. For example, again, So this is our bodyguard in our society. We won't let anyone come in our society, like anyone. If someone is crossing in our society, he'll just, do the barking stuff to scare the outsider. This is how he protects us. So whenever he sees that, okay, now sun has gone, there is night, he'll say, okay, now I am the bodyguard. This is my family, I need to protect them. So he's into that now. Yes, we're able to listen, right? Okay. Oh God, like very aggressive today. Very aggressive. Are you able to listen? Ma'am? Okay. So, guys, let us see. For example, the solvent. This is solvent particles which has higher concentration C2, and here solvent particles have lower concentration. Right? If we say C2 is more than C1, then I say P2 is also more than P1. Right? Because they are directly proportional to each other. So, how will the solvent particles move? The solvent particles are going to move from this to this direction. They are going to move from this direction to this direction. That is from this direction to this direction. And that is the movement of solvent particles. If I say this is the second compartment, this is the first compartment, they are going to move from second to first. Now what is osmotic pressure? Osmotic pressure is that pressure which I apply to stop the osmosis. When I say I need to stop this, what I'll do? I'll apply the pressure. Okay, I'll apply the pressure on this side. I'll apply the pressure on this side. On applying the pressure, okay, the concentration is going to increase. Don't worry, we give him food on time. He's just on that bodyguard mood right now. He's always on this bodyguard mood. He have to protect everyone. He's like a child to us. So, yeah. So, now, bacha, we have this C1. Okay. Now, I am applying pressure on this side. Osmosis is what? Osmosis is the movement of solvent particles from higher concentration to lower concentration. This is osmosis. When we stop the osmosis by applying the external pressure, that is called osmotic pressure. Okay. When we stop osmosis, osmotic pressure is that when we stop osmosis. Osmotic pressure is that when we stop osmosis, right? When we stop osmosis, that is called osmotic pressure. I'll write here. Or what is osmosis? Osmosis is the movement of solvent particles from the second compartment to first compartment. Here we are going to stop it. And what is reverse osmosis, everyone? What is reverse osmosis? What is reverse osmosis? Everyone here, what is reverse osmosis? When I say that I want to stop this, okay, you have stopped this, but you are applying the external pressure, that pi that you have applied, the external pressure that you have applied, the osmotic pressure that you have applied is actually more than the original pressure here. It is even more than this pressure, the pressure of this C2 here, this P2 here, right? Then we say it is going to, the solvent particles are going to move from first compartment to second. Okay, these are the movement of solvent particles. This is the movement of solvent particles. This is the movement of solvent particles. Okay. Yes, bacha. At midnight, he sleeps inside our houses. Like, yes, he sleeps inside our houses. So that way, he's sleeping. Like, very calmly, he's sleeping. So, this is the thing. Okay, this is osmotic. This is reverse. This is osmotic pressure. When we stop the osmosis, reverse osmosis is when the osmotic pressure is more than which is required. Then the solvent particles will move in an opposite direction. Right? That is reverse osmosis. So now how reverse osmosis is used? A student wrote it here. That is desalination. Which student wrote it here? I saw a message of GK, I guess. He has deleted his message. Now desalination. Okay, this is used in desalination. How you will use it in desalination? For example, you have a beaker. you have this semi-permeable membrane here. For example, you have, this is a solution of NaCl plus water. This is a solution only of water. This is a solution only of water. Now you know that this is the first compartment thing. Let us see, I am writing this is as the second compartment only. Okay, because otherwise you will get confused. This is the second compartment, this is the first compartment. Okay, this is the first compartment. Right, this is the first compartment, this is the second compartment. Now what I am writing it here, that when I say there will be osmosis, the moment, because in this you have, in the second compartment, you have less solvent. Okay, here you have more solvent. Here you have more solvent. Right, here you have more solvent. So I'll write that in osmosis, during osmosis, it will move from first compartment higher concentration to lower, first to second. But please don't get confused by this. Okay, either I'll do one thing, I will not write this NaCl plus water here, I'll write NaCl plus water here. You will really get confused in this, okay, because I have taken different examples. So this is NaCl plus water, right? This is water, okay, this is water, right? So I'll write here, this is water, this is NaCl is also added here, right? So this will have less solvent, this will have more solvent, everyone, this will have more solvent, right, this will have more solvent, right, this will have less solvent, this will have more solvent. So now what I am going to say, that here osmosis, that means movement of solvent particles from more to less side. That means second to first. Okay, second to first. If I say that what is reverse osmosis? Reverse osmosis is movement of NaCl. Movement of water, movement of water. Water is the solvent particle, na? Okay, this is the movement of water from second to first compartment. That means the water particle will move from second compartment to first compartment. Oh, first to second. Okay, I'll write first to second. This is from first to second compartment. Okay, where you have less solvent particle to more solvent particle. This is reverse osmosis. So now what will happen? All the water content will be moved to the second compartment, and hence after the reverse osmosis there will be desalination. Okay, there will be desalination. This water will be desalined from what is this? This is salination. This is saline water, that means which have salt in it. Okay, so when this water will move to the second compartment, there will be the water will be free of salt, that is desalination. Okay, that is called desalination. Okay, that is called desalination. Right, everyone? Okay, this is called desalination. Okay, everyone, is this clear to all of you or not? Everyone in the comment section, is this clear or not? Yes, everyone, is this clear or not? Yes, everyone, is this clear or not? Oh my god, after watching I am getting depressed now. Okay, so this is the equation and this is the reverse osmosis that I have taught you. Now what is isotonic, what is hypotonic, what is hypertonic? Everyone, what is isotonic, what is hypertonic, what is this? Wait, how much is left? Things are left even now. Okay, we have want of factor, everything is left now. Okay, yes. Okay, now we have next thing, that is type of solution based on the osmotic pressure. Now first is isotonic, hypotonic, hypertonic. Isotonic is that when you have osmotic pressure is same. Hypotonic is that when a solution which has less osmotic pressure than the other solution. Okay, one will have less osmotic pressure, other will have more. Hyper is always more. Okay, and hypo is always less. In terms of chemistry, hyper is more, hypo is less. Okay, so hypo is that which has less osmotic pressure, and hypo is that which has higher amount of osmotic pressure. So what happens in our cells? Whenever you have intravenous injections? Okay, so there is our cell have one type of concentration, that is 0.9%. Okay, it has 0.9% of NaCl solution. I think somewhat about that is added to our injections, intravenous injection, right? So now what happens when we have something more than that? When there is more the pressure, okay, when we say the concentration is little different as compared to that, disastrous thing can happen. So what are these disasters that can happen, everyone? What are these disasters that can happen? Okay, let us talk about hypo. Okay, let us talk about hypo. Let us firstly talk about hypo solution. For hypo solution, I am saying that you have, this is the red blood cell. This is the red blood cell, and in this red blood cell, for example, this is the red blood cell. Okay, this is the red blood cell, right? Now what I am saying, that you are injecting a intravenous injection which is having 0.9% less concentration. That means, everyone here, if the concentration is less, that means the solute particle is less. The concentration less means the solute particle is, the concentration is less, yes. The concentration is less than this. That means the solute particle is less than this. That means the solvent particle is more than this. Right? Understood? Now this is the concentration. Right? That means the solute. We always know in concentration we have solute by solution. If this is, the concentration is less, the percentage is less, that means solute particle is less. Right? Because percentage is equals to solute divided by solution. Right? So that means solute particle is less. Solvent particle is more because they are inversely proportional to each other. This is less, that means this concentration is going to be more. Now, we know that in osmosis, there is concentration is from higher to lower. Now we have, this is more concentration and this is having less concentration. More concentration of solvent. This is having less concentration. This is our cell, this is injection, right? This is injection, this is our cell. That means our cell is having less concentration of solvent, that is water. Okay, that is water. So now what is going to happen due to osmosis? This is going to move from higher concentration to lower concentration, and thus our cell will swell up. Okay, our cell is going to swell up in this case. Yes, everyone, our cell is going to swell up in this case. Everyone, you have less concentration, that means solute is less. If the solute is less, that means solvent has more concentration. If the solvent has more concentration, okay, this is having less concentration of water, this is having more concentration of water. Okay, the water content will move from more to less. Okay, that is how we say, this is in comparison. That means the cell is going to swell up, right? Okay, now we say totally opposite, that is hypertonic. If we talk about hypertonic, what is the case with hypertonic? If this is talk with hypertonic solution. Hypertonic solution means the percentage is more. Okay, the percentage here is more. That means here I say the solute particle is more. Okay, the solute particle is more. Okay, the solvent particle is less. That means here the concentration of solvent is less, bacha. Here the concentration of solvent is less. This is more. This concentration is more. Right? So here we will say the cell will. Okay, the cell is going to, the water content is going to move from, everyone. This is going to move from more concentration to less concentration. here we will say that this cell will shrink. Okay, our cell will shrink. Yes, everyone, our cell is going to shrink here. Our cell will shrink. Okay, will shrink. Very simple way to learn this is the method how this happens, and very simple way to learn this is that for example, this is shrink. Okay, whenever something is hyper, I said don't get hyper, don't get angry, right? Don't get angry. Whenever someone gets angry, they get shrink. They are very they're like uttering some bad words or anything, so their soul gets shrink at that time, right? Okay, so their face has no glow. When you are you're angry, you are speaking bad about someone, your face is having no glow at that time. When you are happy, you are glowing, right? So this is what they're saying. When you have hyper, you're very hyperactive, you are showing anger, you will shrink. Okay, simple way to learn this. Okay, yes bacha. Okay, yes. Now bacha, we have next question. Let us do this. The question here is, everyone, the question here is the freezing point depression, everyone. The freezing point depression constant, that is Kf of benzene, is this much. This is the freezing point depression. The freezing point depression for the freezing point depression constant, that is given to you, Kf is given to you. The freezing point depression for the solution of molality is given to you containing a non-electrolyte solution in benzene is this. Okay, they are asking the freezing point depression for the solution, that is delta Tf is equals to Kf into molality. Molality is given to you, Kf is given to you. They are asking you the freezing point depression, that is they are asking you the delta Tf. Okay, this is they are asking you the delta Tf. Yes bacha, this is live anonymous. Okay, this is delta Tf. Okay, delta Tf. Now just calculate this, okay, and you will get your answer. Okay, just calculate, put the values, you will get the answer. Next question, 2011, that they asked here. 200 milliliters of aqueous solution of protein contains 1.2 gram, 1.26 gram. Okay. The osmotic pressure of this solution at 300 Kelvin is found to be this much. The molar mass of the protein will be. Okay. Okay. Pi is equals to N by VRT. R is given to you. Temperature is given to you. They have given you the osmotic pressure here, right? They have given you the volume here, right? And mass is also given to you. So you can write pi is equals to W by molar mass into volume RT. Okay? So everything is given to you except for one thing, that is, just not one thing is given to you, that is molar mass. You just have to find the molar mass here. Okay, this is the pi. Okay, I'll write the values. Volume is this one. Okay, I'll just write the values here. Right, this is the volume that is given to you. Right, contains this much of mass. This is the W that is given to you. Right, the osmotic pressure. This is the temperature that is given to you. This is the value of R that is given to you. The osmotic pressure. This is the value of pi that is given to you. Right, you just have to find the value of M, that is molar mass here. And that is going to be your answer. Yes, everyone? Okay? Done? Okay? Yes. Now, let us do the next question. Last topic of today, that is Hoff factor. So, are you all ready for Hoff factor? So guys, are you all ready for Hoff factor? Yes, everyone. Are you all ready? Are you all ready for Hoff factor? Yes? Okay. Everyone in the comment section, are you all ready or not? Only then I'll, proceed further. Otherwise, I'll just stay here. Okay. Yes, students. Yes, students, are you ready or not? Ready? Ready, steady, India, go. Yes? Okay. Now let us see what is abnormal molecular mass, what is normal molecular mass. See, there are two types of things. One is association, one is dissociation. If I talk about dissociation and if I talk about association, here I talk about association. Okay, here we talk about association and this is dissociation. Now see this. If I talk about association here, what is association? What is association, everyone? And what is dissociation? For example, you have MgCl2. This will be dissociated into Mg2 positive plus Cl2Cl negative. Right? Right? Because whenever we have a whenever we have an electrolyte that is getting dissociated, okay, like NaCl will give 2 ions, MgCl2 will give 3 ions, AlCl3 will give 4 ions, okay. So the things that are going to give us ions here, that are electrolytes. When we talk about urea, when we talk about glucose, they are non-electrolytes. They are not going to get dissociated. And because of dissociation and association, we will have this Hoff factor. So now, and firstly, let us learn these two things are interconnected to each other. Right? And now this is your association. For example, we are talking about CH3COH. We know this forms a dimer. Okay, this forms a dimer. It will give us 2 molecules of CH3 will give us 1 molecule of COH dimer. Okay, this will form a dimer. Now, ma'am, what is abnormal and what is normal? Everyone here, what do you mean by molecular mass? What do you mean by molecular mass? Molecular mass is the mass of one molecule, right? Or we can say molecular mass is the mass of 1 mole of molecule. That is same, right? Okay, 1 molecule, that means we will write it in U. 1 molar means we will write it in gram per mole, right? Okay, we can say we are just calculating it for 1 mole or 1 molecule, right? Okay, so if I say the molecular mass should be, it should be MgCl2, that is, everyone, that is, what should be the mass? Okay, what is the mass of MgCl2? Let it be, chalo, let us take an example. That is, I think, totally forgot about this. Okay, what is the mass of Mg? Okay, beta mange car scooter. Wait. What is the mass of Mg? Okay, 24. I totally forgot about it. Okay, so yeah, that is 24. 24 plus you have 35.5 into 2, right? This is going to be the mass. Okay, this is going to be the mass of 1 molecule, right? This is going to be the mass. Everyone calculate it. This is going to be the mass of this. It's going to be 71, right? 71 plus 24, that is going to be 5, 7, 8, 9, something around 95, I guess. Okay, something around 95 should be the molecular mass, should be the molar mass, right? That should be, that is the normal molar mass. That is the normal molar mass. Now, when I say for 1 molecule, that is around 95, right? But when there is dissociation and I'll pick 1 molecule, that will not be 1 molecule. That will be 1 Mg2 positive ion. That may be 1 Cl negative ion. That may be other Cl negative ion. That means that after dissociation, the molecular mass decreases, right? The molecular mass here decreases, right? That is abnormal. The molecular mass decreases. That is the abnormal molecular mass. Okay, that is the abnormal molecular mass. Now if I talk about this CH3, what is the molar mass of acetic acid? 12 plus 3, 12 to 24, 32 plus 4, that is 4, 8, 9, 10, 3, 4, 5, 6, 60. Right? Okay. Here we know that molecular mass, okay, normal molecular mass should be 60. But what we observe, that abnormal molecular mass, abnormal, that means in a mixture, if I say that there is no dimerization, I want to pick one molecule, I'll pick one molecule and it should be 60. But in actual practice, I picked that one molecule. What it came out to be? It came out to be 120. That means one molecule is having double the molecular mass. That means there is dimerization. If one molecule is having triple the molecular mass, that means it is having trimerization. Okay, there is trimer. Okay? Yes, bacha? So, this is the abnormal and normal molecular mass. Why this is happening? Because of the dissociation or the association. Right? Association means to form trimer, dimer. Dissociation means to getting dissolved, getting splitted into the ions. Okay? Right? Yes, to getting dissociated into the ions. Right? So, that is the reason we have this. This is the abnormal molecular mass. It says such molar mass either lower or higher than the expected value is called abnormal molecular mass. Yes, bacha. So next see we have the solution must be this, the concentration of this. Okay, this is not in use. Now let us talk about this is association, this is dissociation. Already done. Now let us talk about Hoff factor. Now what is this Hoff factor? This Hoff factor, okay, this is that factor which defines that. We know that there is not 100% dissociation. Not 100% dissociation. Right? So we cannot exactly find out how many ions are getting dissociated. For that, for the clarification, we have Hoff factor. Because some things are 70% associated, sometimes it is 30% associated, right? Sometimes it is 30% associated. So for that, we have I. That is equals to, all these three formulas are important for you. That is equals to observed colligative property. Why observed colligative property, bacha? We know that colligative property is directly proportional to number of solute particles. Now, if we have association, the number of particles are getting decreased because two molecules are now one molecule. If there is dimer, okay, if there is dimer, two molecules of acetic acid are combined together to form one molecule here. That means there are less number of molecules. The colligative property number will decrease here, right? If there is dissociation, for that if there is dissociation, number of particles will be more, right? Instead of one molecule of MgCl2, you will have three molecules. That is one molecule of Mg2 positive and two molecules of Cl negative. So number of particles are getting increased. That means colligative property is increasing here, right, bacha? Okay, thank you, bacha. Okay, thank you, beta. Thank you so much. Okay, so colligative property is increased here. Number of particles are increased, colligative property is increased. So because number of particles are more, in dissociation, colligative property is more. That means that is going to affect the colligative properties. All the formulas will be changed. Right? Okay. So now this means there should be one factor for that. That factor is called Hoff factor. For that we need to know these three formulas. That is observed colligative property divided by normal colligative property. Right? Okay, observe that we thought, okay, that we observed means that is actually calculated. Okay, in reality, what is? Okay, this is a normal, that was the expected colligative property, right? Normal actual weight, that was actually, if we talk about acetic acid, that should be 60, but observed was 120. So we say the Hoff factor is half here. We say the Hoff factor will be half here. Okay, yes. And if I say I is equals to actual number of particles, the number of solute particles that you have divided by number of particles where there is no ionization, there is no association, there is no dissociation, right? So out of this formula is very important, this formula is very important, and this formula is also important, right? Okay, they can ask you this. Now bacha, let us, all these formulas will be converted. Okay, how these formulas will be converted, let us see. Okay, so all these formulas, just give me a minute. Okay, just okay. So all these formulas will be like this. All these formulas will be like everyone. Okay, all these formulas will be, here I'll have I, Bond factor, here also I'll have I, here also I'll have I, here also I will have I here. Okay, so all these formulas are going to get changed. Okay, all these formulas will be changed here. Yes everyone, all these formulas are going to include now Bond factor. Yes everyone, ma'am, isomerism. Okay, bacha, yes, isomerism I have already done. Isomerism for organic chemistry, we have already done that. Okay, yes, you can watch those lectures in detail, and after that also I am going to revise that. Yes, but revision will be very crisp. Okay, if you want to go into detail, you can watch those lectures, right? Okay, so now let us talk about bacha the formulas. Very important. Okay, for association and dissociation. For association, always I is less than 1. Because if we say normal divided by abnormal mass, normal mass was 60, abnormal was 120, so I came out to be half, right? That is how we say I is always less than 1 for association and always more than 1 for dissociation, right? And what is the formula? I is equals to 1 minus alpha, right? You can say 1 minus alpha plus alpha by n, right? I is equals to 1 minus alpha plus n alpha. So alpha is the degree of dissociation and this is alpha is the degree of association. This is alpha is the degree of dissociation. Okay, this is a very important formula. These two are very important formula. Very important formula. Okay, so definitely they will ask you question, either any conceptual question or any numerical based question will be asked from these kind of these two formulas. Okay, because they are included in to calculate the Van't factor, to calculate the colligative property, right? So they can give you degree of dissociation and then you will calculate the Van't factor, then you will put the Van't factor in the colligative property, then you will calculate the colligative property. Okay, so this is how these kind of questions are asked. Okay, non-electrolytes like urea, sucrose, glucose are taken as 1. They have value as 1. Their value is equals to 1. Right? Okay. So now these are the important points, like more the value of Van't factor, more will be the colligative property because it is directly proportional. It means more is the number of ions given by one molecule, more is the depression. It means more is this, same is the thing. Okay. Okay. All the factors will be more. All the factors will be more. More is the Van't factor. Okay. Yes. Now let us do the questions based on this, everyone. Let us do the questions based on this. Yes, everyone. Let us do the questions based on this. Everyone, let us do the question based on this. The Van't factor for dilute aqueous solution, of the strong electrolyte of barium hydroxide. Barium hydroxide. Here it will be split into Ba2 positive. It will be dissociated to O2 negative. That is N is equals to 3. Okay, Van't factor for dilute aqueous of strong electrolyte. That means the alpha is equals to 1. There is 100% dissociation, right? For that, it will have 3. A Van't factor will be equals to 3 because alpha will have values equals to 1. So answer is going to be 3 here. Okay, answer is going to be 3. Okay, this is the Van't factor, right? Now, next question is 2021 question. Okay, 2021 question. Yes, students. Bacha, just wait for 5 minutes. I'll tell you a link. There you will get the notes for hydrocarbons. Okay, just wait for 5 minutes. Okay. Now, let us see the following solutions were prepared by dissolving 10 gram of glucose. Now, how these solutions were formed? The following solutions were prepared by dissolving 10 gram of glucose. This is your W2 in 250 milliliter of water. 10 gram of urea in 250 milliliter of water. 10 gram of sucrose in this much of water. So, water is same, right? Water is same here, right? Water is same. The mass of urea and all these are also same. This is also non-electrolyte. This is also non-electrolyte. Non-electrolyte. The right option for the decreasing order of osmotic pressure. See, pi is equals to CRT. Right? Temperature here is constant. Is it? Temperature is constant. We see temperature is constant. R is also constant. Pi is directly proportional to C. We can say pi is directly proportional number of molecules by volume. Volume is same, 250, 250, 250, right? So that means this is directly proportional to number of moles. Okay, volume is also same, right? If we say here we have N by VRT, here this is constant, this is constant, this is also constant. So that means it is directly proportional to osmotic pressure is directly proportional to number of moles. Now what is number of moles? Number of moles equals to weight by molar mass. Now weight is also same, but weight is also same, right? So weight is also same. So we write here that is inversely proportional to molar mass. Simple question to ask in 2021. Just 2 years back, right? So pi is inversely proportional to molar mass. Just calculate the molar mass here. Just calculate the molar mass here, right? Calculate the molar mass here. Opposite will be the order of osmotic pressure. Yes, students. Yes. Okay. Let us calculate the molar mass here. Okay. You calculate the molar mass. Okay. What is the molar mass? Molar mass. Molar mass. Molar mass. Molar mass. The molar mass is in the order sucrose. Then you have glucose, then you have this. This is the order of molar mass. You can calculate that. Okay, you can calculate that. Now, opposite is the order of pressure. Okay, so order of pressure will be opposite to that. Yes, okay. Yes, everyone. For example, this is your glucose is 1, this is 2, this is 3. Okay, so say you have 3, then you have 1, then you have 2. Right, that means the answer is going to be 3 less than 1, then 2. Okay, then you have 2. So this is going to be the osmotic pressure 312, 312, 312. That is 312. Yes, 3 is less. So this is A. Yes, bacha, very good. Yes, A is the correct answer. Yes, everyone. Okay, yes. Now we have completed this chapter. Now for all those students who wants to get enrolled into this crash course, that is totally in English. Okay, if you want to get enrolled to a crash course, that is totally in English. That is your batch. Okay, so now what we are going to cover here, live sessions with in-session doubt clearing, right? Because you will have the experience of offline classes here. Then next you have 15 full length mock test and 20 practice test. Now this is the need of the hour, right? This is your need, right? You will have, according to the reduced syllabus, the expected questions, you will have the 15 full length mock test and 20 practice tests. 20 practice, total you have 20 plus 30, 35. If you buy it now, you will be able to solve it, right? So time is less, right? Time is less. You have total 35 full length mock test, right? 20 practice test you have, right? Next bacha, you have comprehensive test analysis and weakness identification. So what we do in our platform, what we take the doubt sessions in that platform, right? Individual doubts are cleared in that way, right? Okay, so all the doubts will be catered in that platform, right? Okay, yes, and that is only just for 4,000. Okay, your destiny in just 4,000, right? Okay, your dream is in 4,000, right? So this is available to you in 4,000. I'll tell you how to get enrolled to that. Let us see how to get enrolled to that. This is your crash course, right? Just go through this, view course plans, okay? Then wait. I think this is increasing. Now this is 5,000. Okay, earlier it was 4,000, maybe 1,000 has increased now. So see, time is near. Okay, so buy it now, right? Because this is very less amount. If I tell you about my time, this is nothing in comparison to that. The value content, if we are providing you free content like this, we're giving you this kind of free content, what will be provided in 4,000 to 5,000? You have no idea to that, right? Obviously, if we have maintained the free content, the paid content will be of next level, right? Okay. So what is the difference? The difference is that the individual attention, the individual weaknesses that you're using. For example, you are currently at 500 marks. You have currently at 600 marks. By enrolling to the course, by the teacher experience and by the live interactions, here also you have live interactions, but in that the system is very no spammers, nothing is there, only concentrated terms are followed there, right? Also there is one-on-one doubt solving sessions. So in that way you will be able to ask the doubts that okay, these are the things where I have weaknesses, these are the topics where I lag, in those topics, right? In those topics, how to get strengthened in those topics, that the teachers will provide you, right? If you are feeling like the orientations will be taken, right? Which course to get enrolled to, what are your marks, all these things will be done in the crash course, right? Okay, so yes. Now, bacha, next thing that one student was asking, see, wait. Now, this is the coupon, that is DKCC, that you have to use for 50% off, right? You just have to use this coupon, that is DKCC, Diksha Kaushal, okay? DKCC to get 50% off on that. Okay, bacha? Yes. Okay, next bacha we have, use the coupons, okay? Because you will get 50% off, right? Now see this. Now someone was asking, ma'am, how to get the notes. Wait. I think the notes, I'll upload the notes here. I think the notes are not uploaded here. Wait, I'll see. Wait. So wait, I'll upload the notes. All the notes will be uploaded on these class notes, or you can directly go to the comment section here. Okay, the notes, so for example, you are watching the hydrocarbons chapter. The notes will be in the comment section as well. And you can also, I'll update the notes here. Okay, class notes, I'll update the notes according to all the chapters that we have done till now. All the notes will be updated here. Okay, this is the treasure box. Just click on that, and here all the notes will be uploaded by me. Okay, I'll upload all the notes here. And what else you get here? You get the PYQs test now. For example, we have taken the what we have done today. We have done solutions today, right? So this is the PYQ test of solutions. So just go through that, start the test. This is your PYQs test, right? Okay, this is your PYQ section A, section B, all these things, right? Okay, so now if you want to see the NCERT questions, so these are your NCERT solutions. As you can see, these are your NCERT solutions, right? NCERT is very important, PYQs are very important, then mock test and test series are important. If you are doing all that now, you're already winning the race, right? You're already winning the race, but time is less. If even now I have to motivate you for this, No, I don't know when you will get motivated by yourself. Okay, so these are the, wait. These are the, I have clicked on environmental chemistry. Wait. So these are the solution questions. Okay, these are your NEET solution. NEET questions are asked from the solution chapter. Okay, so these are all the questions that are asked from the solution chapters. Okay, understood? Yes, everyone. And now this is your CBSE PYQs. You don't have to do that. Okay, just do the NEET PYQs, do the NCERT questions. Okay, then do the mock test, practice test. All those things are very important for you. Yes, everyone. Okay. Yes. Motivation should always be intrinsic. If it is intrinsic, if it is coming out of your own mind, on your own thinking, right? In that way, you will be able to, yes, you will be motivated for a longer time. If that is extrinsic, I will motivate you for one day, then again you will get demotivated. It's not, it doesn't work like that. There will be one day nobody is going to motivate you. You will get bored, right? And then you will feel like, now nobody is motivating me, what should I do? Right? So motivation should be intrinsic. Yes, there are times when you will feel demotivated because the exam is very near. But we are here for you. We are not here to motivate you to study. We are here to maintain that balance, that you get stressed out. For that stress, we are here. You feel that, okay, ma'am, we are feeling stressed, then we are here. You feel, ma'am, we need motivation to study, then we are not here. Because if I have to give you motivation for study at this point, then bacha, this is wrong. Then you are on the wrong track. Because if the dream is big now, you have to work hard. The dream is to be a doctor, right? Doctor is something that requires a lot of knowledge. Somebody is giving you their life. Somebody is trusting you for their life. You go to any shop, you just say, oh my God, this is so costly, I want to bargain. Do you bargain in front of doctors? Do you bargain? Do you say, no, this medicine is so costly, I won't, just give me some other medicine? You can't. Because you have blind faith on them. And you are going to be that doctor. So how can you say that you don't have to do any hard work? How is that possible? Without doing hard work, how can you get into that position that requires the most trust? Right? So do the hard work. It's not only now that you're doing the hard work. You have to do the hard work when you get into MBBS college. You have to do the hard work in the first year, second year, third year, fourth year, fifth year. Even after MBBS, you have to do the hard work. Even after becoming the best doctor, you have to be updated regarding, in COVID times, all these doctors were very updated regarding what things should be given. Right? Why? Because you have to, you are reliable. You are actually there, you are responsible for that. And when somebody is giving you the position of God, right? You have to be very responsible, very active, very, up to date for that. So, if you want to be a doctor, remember this hard work is not only for NEET. This hard work is going to get throughout your life. Even if I say being a teacher, yes, I am a teacher, I have to do hard work. Not only when I was doing BSc, not when I was doing B.Ed, not when I was doing MSc, but I have to do hard work throughout my life. Why? What is the reason? Because if I stop doing hard work, how will I get updated? How will I analyze what is the pattern? How will I teach my students? How will I help them? Right? So in every profession you have to do hard work. But in doctors, the mistake is going to, destroy someone's life, destroy someone's health, right? That mistake is going to destroy someone's health, and health is something which cannot be gained after that. So you are going to be very responsible for someone. Do take care of that. Okay? Yes. Okay. Yes, students. Engineer, you still can bargain, okay? With doctor, you can't. With doctor, you can't. Engineer, you can bargain, right? But you can't bargain with a doctor. You can't say that, okay, I don't want to do this surgery. Let's do this minor surgery. No, why to do this major surgery? Let's do this minor surgery. This will cost less. You can do that while you are decorating your house. Okay, I don't want this down ceiling because this is costing me so much. Okay, let's do paint. Let's do whitewashing. Why? Because you can do that. But you can't do that for your health. Right? So, yes. Always take care of this thing. You are going to be a very responsible individual after you step out of this student life. Right? So work hard and do not get stressed about anything. We are always here for you. And if you are preparing for NEET 2024, that's my advice to get into this crash course. Right? You will get 50% off by applying DKCC. Right? Apply that, get the crash course, attend the live classes. Attend the doubt solving classes, attend the orientation sessions, attend the also give the mock test, also give the test series. Okay, all these things are very important for you right now. Yes, bacha. Okay, thank you, bacha. Thank you. Okay, then bye bye everyone. See you all. Take care. Bye bye.